In the beginning, there was no beginning. Only silence, a vibration waiting to be born. Every atom in your body was once forged in a star, every heartbeat an echo of the universe remembering itself. We look up and see infinity. The same infinity hums inside us. From the trembling strings of quantum foam to the red edges of the cosmic horizon. Like and subscribe if you love wondering about where it all began. Tonight, we'll drift through that story, from nothing to everything. From the birth of time to the final whisper of entropy. Now, close your eyes. Let's begin. Before space, before time, there was only potential, a silence so deep it had no dimension. Then, in an instant, the universe exploded into being, not from somewhere, but from nothing. A single flash of expansion birthed all matter, energy, and time itself. No human word can quite describe what that moment was. The Big Bang wasn't an explosion in space, it was the creation of space itself. There was no center, no edge, no before. It was everywhere, all at once, an unfurling of reality from a point that contained everything that would ever exist. Within less than a trillionth of a second, the newborn universe expanded faster than light, stretching the very fabric of existence like a balloon filling with eternity. Temperatures soared to levels beyond imagination, billions upon billions of degrees, energy condensed into particles, tiny seeds of matter that would one day become stars, planets, and people. Photons, the particles of light, flickered into existence, colliding in a chaotic ocean of raw creation. This was not order, not beauty at least, not yet. It was chaos made fertile. The universe was pure potential in motion. Time began to tick, though tick is too slow a word for the furious unfolding that followed. In less than a second, forces that would define everything, gravity, electromagnetism, and the strong and weak nuclear interactions, froze into being. The laws of physics were written in that instant, encoded into the structure of reality like a cosmic operating system. Every galaxy, every mountain, every thought that would ever occur began as a possibility contained within those first blinding moments. As expansion continued, the universe began to cool. Energy slowed, and matter started to take shape. Protons found electrons, clinging together to form the first hydrogen atoms. The simplest building blocks of all future stars. From pure energy came the first whispers of substance, and from perfect symmetry came imperfection, the imbalance that made everything possible. For reasons still unknown, matter ever so slightly outnumbered antimatter. When they met, they annihilated in flashes of light, but those few extra particles of matter remained. Those leftovers became the universe we know. Imagine the scale of it, the entire cosmos, now stretching billions of light years across, once smaller than an atom. Every star you see, every galaxy we will ever discover, was once compressed into something you could hold in your hand, if hands had existed back then. From absolute nothingness came everything: gravity, galaxies, starlight, and the quiet awareness that now listens to this story. And yet, even now, the question lingers like a faint hum beneath all existence: why? Why was there something rather than nothing? Science can tell us how, but not why. Perhaps there never was a why. Perhaps the universe is simply what nothing does when it stops being nothing. Close your eyes and imagine it. The birth of everything, the instant when silence became sound and emptiness bloomed into stars. The cosmos began not with chaos or destruction, but with expansion, a gentle unfolding of possibility. From nothing, the universe became everything, and somewhere in that eternal beginning, the story of you had already begun. In the first heartbeat of existence, temperatures soared beyond imagination. Quarks fused into protons, photons scattered wildly, and gravity took its first breath. The universe wasn't empty, it was a storm of becoming. Everything that will ever exist was still crowded together in a space smaller than an atom. Yet it was already expanding faster than light could chase itself. This wasn't an explosion through space. It was the creation of space itself, rushing outward, unfolding like a cosmic bloom. The very idea of distance was being invented as reality raced into form. Energy swirled in searing plasma, a sea so dense that light couldn't travel more than a fraction of a millimeter before being swallowed again. Every photon collided, rebounded, and vanished into the furious glow of creation. In those first trillionths of a second, matter and antimatter danced their deadly duet. For every particle of matter, there was its mirror opposite, destined to collide and vanish in a flash of light. Yet for reasons still hidden in the mathematics of the universe, there was a tiny imbalance. One extra particle of matter for every billion annihilations. Those few survivors became everything. Every mountain, every ocean, every person who would ever look up at the stars, all born from that exquisite cosmic flaw. Gravity, though impossibly weak compared to the fury of the other forces, began to do its quiet work. Where particles clumped, gravity whispered, "Stay." In those whispers lay the promise of galaxies. Meanwhile, the strong nuclear force, the mightiest of them all, held protons and neutrons together in atomic harmony, forming the first hydrogen and helium nuclei. In just microseconds, the universe was no longer pure energy. It had structure, it had rules, it had a destiny. The temperature was still over 1 trillion degrees, so hot that matter itself quivered on the edge of existence. A single teaspoon of this primordial fireball would have weighed billions of tons. Space expanded with inconceivable speed, doubling again and again, stretching the newborn fabric of reality to thousands of times its original size in less than an eye blink. This period, known as cosmic inflation, smoothed the chaos, turning the quantum jitters of nothingness into the seeds of galaxies. Every vibration in that early sea of energy left ripples that still echo through space today. The faint murmur we call the cosmic microwave background. Those ancient waves are the heartbeat of the first second, still pulsing softly through every corner of the universe, a message from the moment time began. As the expansion slowed, the universe began to cool, though cool meant temperatures dropping from trillions to billions of degrees. The strong nuclear force glued quarks into triplets, protons and neutrons, the fundamental building blocks of all future atoms. Electromagnetic energy flared like lightning across the cosmic ocean, creating a dance between radiation and matter that would last for hundreds of thousands of years. If you could have floated there, you wouldn't have seen stars or light or color, only blinding radiance, a brilliance that filled every direction at once. There was no up or down, no here or there. Space itself was the storm, and you were inside it. Every point of that early cosmos expanded equally, every atom to be rushing away from every other. And yet, amid that violent perfection, something remarkable happened. Simplicity began to give birth to complexity. Out of energy came matter, out of chaos came pattern, and out of the raw fire of existence came the possibility of stability. The first second ended with a universe still in flux, but one that had set its laws in motion, laws that would guide everything that followed. From that first second forward, gravity would gather, light would travel, hydrogen would burn, stars would be born, die, and be reborn again in endless cycles. The seeds of galaxies, black holes, and living worlds all took root in that breath of time. When you look up at the night sky, remember this. Every photon that touches your eyes began its journey in that same storm. The first second was not just the beginning of the universe. For 380,000 years, light was trapped, bouncing between newborn particles in a dense cosmic fog. Only when atoms finally formed did that light break free, spreading outward as the cosmic microwave background, the oldest photograph of the universe. The early cosmos was not yet the starry expanse we imagine when we look up at the night sky. Every photon, every particle of light was caught in an endless dance between electrons and protons, scattering and rebounding in all directions. The universe glowed not with stars but with pure, blinding radiation, a brightness that filled every corner equally. This was a universe without transparency, a place where light could not move farther than a hair's breadth before being absorbed and re-emitted. Imagine a fog so dense that even light itself could not escape. It wasn't darkness that filled the cosmos. It was a brilliance too overwhelming to see. Time and space were bathed in this luminous soup, a haze of light and matter locked together, waiting for the first hint of clarity. As the universe continued to expand, it cooled. What was once trillions of degrees dropped to mere thousands, and with that gentle cooling came a profound transformation. Electrons, those restless sparks that had been colliding endlessly with photons, finally slowed enough to settle into orbits around protons. The first neutral atoms were born. That moment, known as recombination, changed everything. For the first time, the universe became transparent. Light, once imprisoned, was set free to travel unobstructed across the cosmos. The fog lifted. The cosmos exhaled. The very first light burst outward, unshackled, flooding space with the faint afterglow that still surrounds us today. That light is the cosmic microwave background, a relic from the dawn of time. It still drifts through the universe, stretched and softened by billions of years of expansion. What began as brilliant radiation, hot and blinding, has cooled to a whisper, a faint microwave hum just a few degrees above absolute zero. Yet it carries within it the story of everything that followed. Astronomers can still detect it. When a radio telescope looks deep into space, it sees that ancient glow, uniform and omnipresent, a cosmic photograph imprinted with the fingerprints of creation. Within its subtle ripples, tiny variations in temperature, 1 part in 100,000, are the blueprints for all structure, galaxies, stars, and planets. Those minute imperfections are what allowed gravity to sculpt the universe into the patterns we see today. Every time you tune an old television and hear static, a tiny fraction of that hiss is this primordial light. Those photons began their journey almost 14 billion years ago, and some of them are just now reaching your eyes. You are literally seeing the afterglow of the beginning, the faint memory of when the universe first became visible to itself. If you could have stood there in that newborn cosmos, there would be no stars yet, no planets, no galaxies, only a vast golden fog thinning into clarity. The temperature would be roughly 3,000 degrees Celsius, warm enough to glow like molten metal, cool enough for atoms to hold together. As the fog lifted, the universe would have faded from a fierce white blaze into a gentle amber radiance, and then into darkness. That darkness wasn't emptiness, it was possibility. The light had been freed, but now gravity would take over, tugging at the faint irregularities hidden in that afterglow, gathering matter into clouds that would one day ignite as stars. The universe had taken its first breath of clarity, but the next act would require patience. For hundreds of millions of years, that first light would travel through empty space, cooling and dimming, while the cosmos entered a quiet, shadowed age. Yet even now, those same photons continue to move outward, endlessly crossing the cosmic sea. They are time itself, captured in motion, a message from the moment the universe first learned to shine. And when they touch your skin, or your telescope, or your thoughts, remember, you are made of the very atoms that once trapped that light, and you are bathed in the same glow that first revealed the universe. The light that could not escape finally did, and in doing so, it made vision, knowledge, and wonder possible. After the first light faded, darkness returned. No stars yet, only hydrogen clouds adrift in a silent, expanding void. The universe slept, waiting for gravity to sculpt the first sparks of creation. The cosmos was no longer glowing with the brightness of its birth. The last photons of the cosmic background had escaped, leaving behind a universe filled with invisible gas, vast, diffuse, and eerily calm. The temperature had fallen dramatically. What was once a furnace of energy now drifted into chill and shadow. This was the universe's adolescence, a long and patient silence stretching across hundreds of millions of years. If you could somehow stand within that young universe, you would see nothing. No stars, no galaxies, no light at all, only endless blackness threaded with faint wisps of hydrogen. Space was expanding, time was passing, but nothing was yet shining. The cosmos had dimmed to a whisper. Yet even in this darkness, a quiet process was underway. Gravity, the universe's patient sculptor, was beginning its delicate work. Tiny ripples, those same irregularities left imprinted in the cosmic microwave background, had given the universe texture. Some regions were slightly denser than others, and gravity began to draw matter inward toward these invisible centers. Over millions of years, those faint over-densities grew. The hydrogen gas started to clump, forming cold, invisible halos that slowly gathered more material. The first threads of the cosmic web began to form, vast filaments of matter stretching across unimaginable distances, weaving the framework of everything that would one day exist. During this time, the universe was filled with hydrogen and helium, the simplest elements, but it was almost completely neutral, with few charged particles to scatter light. That made it transparent, yet utterly black. The photons of the first light still raced through space, but nothing new was being created to replace them. The universe was visible to no one, not even itself. And yet, this darkness was not lifeless. Deep within those invisible clouds, tiny knots of gravity began to tighten. As hydrogen gas fell inward, it compressed, heating up slowly. Temperature rose, density grew, and in certain places, the balance tipped. The first protostars, still unseen, still hidden inside dense cocoons, began to stir. The cosmic dark ages lasted roughly 200 million years. During that immense stretch of time, the universe's expansion continued, stretching the background light until it was too faint for even the most sensitive instruments to detect. It was a silent symphony of waiting. Matter moved gently under gravity's pull, like dust swirling in a slow, invisible wind. Astronomers today call this era dark, not just because it lacked light, but because it remains one of the least understood periods in cosmic history. No telescope can yet see directly into it. It is hidden by distance, by time, by the sheer scale of what followed. But we can infer its shape through simulations and the faint fingerprints left on the later universe. It was then that the foundation of everything familiar, every star, every planet, every atom in your body, was laid down by gravity's patient hand. Imagine the universe as a vast ocean at night, perfectly still. Beneath the surface, pressure is building. Small waves begin to form, invisible in the darkness, until eventually they will crash into brilliance. The Dark Age was that moment before the first sunrise, the cosmic dawn still sleeping behind a curtain of hydrogen. And then, after eons of stillness, it began. Somewhere, in a dense pocket of gas, pressure and gravity finally reached a critical point. Hydrogen atoms fused, releasing light. The first star ignited, and for the first time since the beginning, darkness had an end. The universe's long night was over. The cosmic dawn had arrived. But for now, in this moment of the story, we pause at the edge of that awakening, on the silent horizon between nothingness and light. Because even in the universe's darkest age, the next chapter of creation was already waiting to begin. Then came the fire. Massive, blue-white giants ignited, burning with ferocity and living for only a few million years. Their death scattered heavy elements, the seeds of planets, oceans, and life. Out of the darkness, pinpricks of light began to appear, fragile, lonely stars born in the emptiness between the great hydrogen clouds. These were not the calm, steady suns we know today. They were titans, colossal furnaces hundreds of times more massive than our sun, burning at temperatures that could melt atoms themselves. For hundreds of millions of years, the universe had waited in silence, and now, at last, it began to glow again. These first stars, called population 3 stars, were pure. They contained only the simplest elements, hydrogen and helium. No carbon, no oxygen, no iron, nothing that we associate with the familiar chemistry of life. Yet their purity made them powerful. Without heavier elements to cool their cores, they burned hotter, brighter, and shorter than any that would come after. Each one was a miniature supernova waiting to happen. As they ignited, they flooded the surrounding space with ultraviolet light, reionizing the neutral hydrogen that had filled the cosmos since the Dark Ages. This transformation, known as the Epoch of Reionization, was the great awakening of the universe. The fog lifted. The cosmic night began to dissolve. For the first time, the universe was filled not only with light, but with structure, color, and energy. Their light pierced the darkness like cosmic lighthouses, illuminating clouds of gas that were slowly gathering into the first galaxies. Though they lived briefly, their impact was eternal. Inside their cores, fusion was forging the building blocks of complexity. Helium into carbon, carbon into oxygen, oxygen into silicon, and finally into iron. When these stars reached the end of their brief lives, they did not fade quietly, they exploded. Their deaths were cataclysmic. Supernovae ripped through the fabric of their surroundings, scattering those newly formed elements into space. The universe, once simple, was now seeded with the ingredients of everything to come. From that stellar debris, new generations of stars would form, stars with planets, with moons, with oceans. The calcium in your bones, the oxygen in your lungs, the iron in your blood, all of it was forged in those first stellar deaths. Every breath you take is a whisper of those ancient fires. If you could witness one of those first stars, it would outshine entire galaxies. It would blaze with a light so intense that shadows could never form near it. These massive stars lived for only a few million years, a blink in cosmic time. They burned themselves out quickly, trading longevity for brilliance. And when they died, the universe mourned them with fireworks of unimaginable scale. In their wake, the first black holes were born. Some grew quietly, feeding on the gas and dust left behind. Others merged and multiplied, becoming the seeds of the supermassive black holes that would one day anchor galaxies. Even in death, the first stars continued shaping the universe, pulling matter into new forms, writing gravity's story in loops of light and shadow. Gradually, their scattered remnants enriched the universe, and the next generation of stars, population 2, began to emerge. These were cooler, more stable, and surrounded by clouds laced with the ashes of their predecessors. The universe had entered a new era, one of recycling, of renewal, of cosmic evolution. Imagine it, a sky with only a few thousand stars, each one impossibly large, burning alone in an ocean of black. No planets yet, no galaxies as we know them, only light finding its voice again after hundreds of millions of years of silence. Every flicker, every fusion reaction, every explosion was a declaration creation had begun. The first stars were the universe's heartbeat, pulsing in radiant bursts across the cosmic web. They taught the darkness how to glow, and from their short, brilliant lives came the possibility of everything. Galaxies, worlds, oceans, and eventually, consciousness. The universe was no longer sleeping. The fire had returned, and it would never go out again. Gravity gathered stars into sprawling cities of light, galaxies, each spinning with billions of suns. From afar, they looked like frozen whirlpools of time, painting the darkness with meaning. In the aftermath of the first stars, the universe was no longer silent. It hummed with energy and light, with the faint gravitational pull of billions of tiny star clusters drifting through expanding space. Gravity, the invisible architect of the cosmos, was slowly, patiently weaving those scattered lights into structure. What began as isolated pockets of brightness began to merge, drawn together by the same ancient force that shapes the tides and keeps your feet pressed to the earth. Over millions of years, gravity sculpted chaos into harmony. Small clusters of stars collided, merging into larger and larger groups. Clouds of hydrogen and helium swirled together, forming immense, rotating disks that would become the first proto-galaxies. These weren't yet the elegant spirals we see in today's telescopes. They were rough and uneven, turbulent with motion, immense storms of gas and light slowly finding their balance. Every collision released tremendous energy, heating the surrounding gas and triggering new bursts of star formation. One generation of stars ignited, burned, and exploded, enriching their surroundings with heavier elements. Another followed, then another. The universe was recycling itself, generation after generation, layer upon layer. The great cosmic structures we see today, the spirals, the ellipticals, the massive galactic clusters, were being assembled one star at a time. If you could have drifted among them, the view would have been beyond comprehension. Massive clouds of glowing hydrogen stretched across light years, pulsing with ultraviolet radiation from newborn stars. Enormous filaments of dark matter extended invisibly through the void, providing the scaffolding that held these galactic cradles together. Where the filaments crossed, galaxies began to form in vast clusters, connected by bridges of light. And then, slowly, shapes emerged. Graceful spirals, glowing ellipses, and irregular galaxies twisted by gravity's pull. The young universe became a cosmic cityscape, its skyline illuminated by billions upon billions of suns. Each galaxy spun like a celestial pinwheel, its spiral arms tracing the slow dance of gravity and momentum. The luminous hearts of these galaxies glowed brightest, home to dense swarms of stars and, at their centers, mysterious points of infinite gravity. Black holes born from the deaths of the first massive stars. Galaxies were not only homes for stars, they were the engines of cosmic evolution. Within them, gravity compressed gas into new suns. Radiation sculpted the surrounding clouds, carving out voids and filaments, shaping the flow of matter itself. Over billions of years, galaxies collided and merged, their stars weaving together into larger structures. Even now, that process continues. The Milky Way, our own spiral of light, is on a slow, inevitable collision course with the Andromeda Galaxy. In 4 billion years, the two will merge into one colossal new galaxy, a luminous testament to the continuing creativity of the universe. Each galaxy, no matter how distant, tells part of the same story. They are the fingerprints of gravity, the evidence of time made visible. When you gaze at the night sky and see the faint smudge of a galaxy millions of light years away, you're not seeing it as it is now. You're seeing it as it was when the first human ancestors were still dreams in the stardust. Every photon that reaches your eyes has traveled for eons, crossing unimaginable distances to deliver a single message. I was there when the universe was young. From the outside, a galaxy seems timeless, an island of light adrift in an infinite ocean. But up close, it is alive, in motion, breathing through the rhythm of its stars. Some are being born, others are dying, and around them, planets spin quietly, holding oceans, skies, and perhaps dreams. Gravity did not just sculpt galaxies, it sculpted possibility. It turned the raw matter of the early universe into order, structure, and beauty. From chaos came pattern, from energy came form, and from that form came the light that now fills the darkness. The galaxies are not distant strangers, they are our ancestors, our architects, our reflection in the mirror of time. Every one of them is a reminder that even the cold pull of gravity can create so. Galaxies didn't float randomly. They wove themselves into filaments stretching across the universe, forming a colossal web of matter and energy, a cosmic nervous system connecting everything. If you could step back far enough, farther than any telescope can yet see, you would notice a pattern. Galaxies are not scattered like grains of sand. They trace a vast and intricate architecture, a lattice of light and shadow stretching across the cosmos. These filaments and clusters form what astronomers call the cosmic web, the grandest structure in existence. It is the universe's skeleton, its invisible framework, its map of destiny. This web began as faint ripples in the energy of the newborn universe, tiny fluctuations in density that grew slowly under the pull of gravity. Regions slightly heavier than their surroundings attracted more matter, while emptier spaces became cosmic voids. Over billions of years, gravity pulled gas, dark matter, and galaxies into these threads, braiding the universe into a structure that resembles neural pathways in a brain or the branching of a river delta. The similarity isn't metaphorical, it's mathematical. The same natural patterns that shape synapses and tree roots also shape the universe itself. At the intersections of these filaments lie galaxy clusters, immense gatherings of thousands of galaxies bound together by gravity, each surrounded by halos of invisible dark matter. Between these clusters stretch filaments of gas and light, sometimes millions of light years long. Within them flow not just galaxies, but the building blocks of everything, streams of hydrogen, helium, and dark matter coursing through the void like cosmic blood. And between those glowing threads, vast emptiness. Cosmic voids, regions so immense they could swallow thousands of galaxies whole, yet so empty that they contain almost nothing at all. They are the silent spaces between the web's strands, the pauses between the universe's notes. Together, filaments and voids form a balance, a rhythm of matter and nothingness that defines the universe's shape. Scientists discovered this structure gradually, through deep sky surveys and simulations that mapped the positions of millions of galaxies. When plotted in 3 dimensions, the data revealed something astonishing. Galaxies arranged in sheets and tendrils, connecting across distances so vast that light itself takes billions of years to cross them. We are living inside one of those filaments now. Our Milky Way rests within the Laniakea supercluster, a colossal region that contains more than 100,000 galaxies, all gently drifting together through space. It's humbling to realize that what we call empty space is not truly empty. The filaments of the cosmic web are threaded with wisps of hot gas, permeated by magnetic fields, and illuminated faintly by ultraviolet light. They are rivers of matter flowing through the void, constantly evolving as galaxies move, collide, and merge. Every atom in your body once traveled through those currents, carried by gravity's invisible hand from one cosmic shore to another. The cosmic web is not static, it's alive with motion. Galaxies migrate along its filaments like leaves carried by a current, slowly falling into clusters where gravity grows stronger. Over time, these great rivers of matter feed the growth of new galaxies and the formation of even larger structures. The universe, it seems, has always been building itself, strand by strand, connection by connection. If you could see it in its entirety, the cosmic web would look like a vast glowing net suspended in darkness, each intersection shining where galaxies gather like fireflies. From a distance, it would shimmer like the neural network of some incomprehensible cosmic mind, each galaxy a thought, each filament a connection, the entire structure pulsing with the slow rhythm of eternity. And perhaps that's not far from the truth. The web connects not just galaxies but moments, not just matter but memory. It is the pathway through which energy and time flow. From the smallest particle to the largest cluster, everything is part of it, woven into the same cosmic fabric that began when the first atoms cooled. When you gaze at the night sky, you are looking along one tiny thread of this vast design. Every star you see is a bead of light upon an invisible string that stretches across the whole of creation. And somewhere, unimaginably far away, another being, on another world, may be looking back along their own strand of the same web, wondering if they, too, are alone. They aren't. None of us are. Because everything, every galaxy, every atom, every thought is connected. The universe is not a collection of separate things, but one immense, living pattern. The cosmic web is its heartbeat, its breath, its infinite, luminous mind. Most of the universe is invisible. Dark matter shapes galaxies with unseen hands, providing the gravitational glue that holds cosmic structures together. Though we cannot see it, it whispers to the luminous stars, guiding their orbits and dictating the grand choreography of the cosmos. Every spiral arm, every cluster, every filament stretching across the cosmic web bears its silent signature. Without dark matter, the galaxies we admire would dissolve into chaos, stars drifting apart without rhyme or reason. We first inferred its existence not by seeing it directly, but by the way stars and gas moved. Galaxies spun faster than the visible matter could account for, as if an invisible scaffold held them together. Clusters of galaxies clung tightly, defying the pull of gravity we could calculate from what we could see. Dark matter became the hidden architect, a silent hand shaping the universe from behind a veil. It interacts weakly, almost imperceptibly, with the ordinary matter we are made of, yet its influence is monumental. Dark matter is not uniform. It forms halos around galaxies, massive envelopes stretching far beyond the stars themselves. These halos merge, collide, and collapse, driving the formation of structures on scales unimaginably vast. In cosmic simulations, when dark matter is included, the universe looks familiar. A network of filaments, knots, and voids. The cosmic web we observe through our telescopes. Remove dark matter from the equation, and that web collapses. Galaxies fail to form, leaving an empty, featureless void. Despite its importance, the nature of dark matter remains one of the deepest mysteries in physics. Is it composed of exotic particles that barely interact with anything else? Does it hide in sterile forms of neutrinos, or perhaps something stranger still, something that defies our current understanding of matter and energy? Experiments deep underground, beneath layers of rock, attempt to catch these elusive particles. Detectors hover in silence, waiting for the faintest whisper of an interaction, a fleeting nudge from this ghostly presence. So far, dark matter has proven remarkably shy, leaving only hints of its existence in the motion of stars and galaxies. Yet, the evidence is compelling. Gravitational lensing, the bending of light by massive structures, reveals concentrations of mass where no stars shine. Entire galaxy clusters are mapped by the invisible hands of dark matter, traced only by the distortion of the light passing through them. Every observation, every simulation, points to a universe sculpted by something we cannot touch or see. Dark matter teaches us humility. It reminds us that the universe is far larger, stranger, and more intricate than what our senses reveal. We are familiar with the glow of stars, the warmth of planets, the brilliance of galaxies, but these are only the surface. The universe's true architects are hidden, their work silent, their presence inferred, and in the quiet, dark embrace of the cosmos, they shape everything we see, shaping our understanding of existence itself. Dark energy, the quiet force accelerating the universe's expansion. It stretches the fabric of space faster than galaxies can cling together, ensuring that everything will someday drift into solitude. Invisible and enigmatic, dark energy is the antithesis of gravity, a gentle yet relentless push that shapes the cosmos on the largest scales. While dark matter binds, dark energy drives apart. It does not cluster or form halos, nor does it interact with stars or planets. Instead, it is the underlying pressure of empty space itself, a property of the cosmos that refuses to remain still. We discovered it by observing distant supernovae, tiny explosions whose light carried the history of cosmic expansion. To our surprise, galaxies were not slowing down under gravity. As we expected, they were speeding up, racing away from one another faster with each passing billion years. Space itself was inflating, stretching like an ever-growing rubber sheet, and the source of this acceleration was invisible. Scientists named it dark energy, a placeholder for something fundamental that we do not yet fully understand. Dark energy dominates the universe. It outweighs the matter we see, both ordinary and dark, by a factor of nearly 3. Yet, its effect is subtle on small scales. Planets orbit stars, galaxies cluster, stars collapse into black holes, all as if nothing had changed. But on the grandest cosmic scales, its influence is undeniable. Galaxy clusters drift apart, the voids between filaments of the cosmic web grow emptier, and the universe's expansion accelerates with quiet inevitability. Its presence poses profound questions. Is dark energy constant, a fixed property of space? Or does it evolve, perhaps changing over cosmic time? Some theories suggest it is a property of a vacuum, an intrinsic energy that exists even in the emptiest regions. Others propose new fields, dynamic entities that stretch space with varying intensity. Every model challenges our understanding of physics, demanding we rethink the fundamental rules that govern the universe. The future painted by dark energy is both majestic and melancholy. Billions of years from now, galaxies beyond our local group will vanish from view, receding faster than light can travel. The night sky, once filled with the glow of countless galaxies, will shrink to a lonely collection of stars within our own cosmic neighborhood. The universe will become a place of isolation, its vastness magnified by the quiet persistence of this invisible force. Yet, dark energy also inspires awe. It is a reminder that the universe is not static, it is alive with motion and transformation. It drives evolution on a scale far beyond human comprehension, shaping destinies of galaxies and the ultimate fate of everything we observe. In the tension between gravity and dark energy, between the pull that binds and the push that separates, we glimpse the profound elegance of the cosmos. Dark energy, though unseen, is a defining character in the story of existence. It teaches us that the universe is a dynamic, ever-expanding mystery, where even emptiness carries weight, and silence can wield unimaginable power. In its quiet dominion, the cosmos continues its inexorable journey, stretching into the unknown, reminding us that the most fundamental truths often lie beyond sight. Our home galaxy began as a swarm of smaller ones colliding. Over billions of years, it became a spiral of calm in a chaotic cosmos, a cradle for future life. In the early universe, matter was scattered in a fog of gas and dark matter, punctuated by pockets of light where the first stars ignited. Tiny proto-galaxies drifted through this young expanse, drawn together by gravity's patient pull. They merged, collided, and tore one another apart, their stars scattering in brilliant bursts of energy, leaving behind the first hints of structure in the otherwise featureless darkness. Each collision left an imprint, a subtle rearrangement of stars and gas that would shape the Milky Way's skeleton. Dark matter provided the unseen framework, a gravitational scaffolding around which these early galaxies coalesced. Streams of stars, remnants of ancient mergers, still arc across the galactic halo, relics of a turbulent youth. It was a time of violence and creation intertwined, when chaos and order danced together, sculpting the architecture that would eventually host solar systems, planets, and life. Over billions of years, these chaotic mergers slowed. The Milky Way began to settle into the familiar spiral we recognize today. Gas clouds cooled and condensed, forming the disk and the spiral arms. Stars continued to ignite, clusters were born, and the galactic center grew dense with both stars and a supermassive black hole. Its gravity anchoring the swirling dance of matter around it. The galaxy became a stable, luminous city amid the expanding darkness, a home that could sustain complexity and, eventually, consciousness. But this calm was not absolute. Streams of matter continued to fall in, minor galaxies were absorbed, and stars still wandered from their birthplaces. The Milky Way remained a living, evolving entity. Its history written in layers of stars, clouds of gas, and scattered dust. Every solar system, every orbiting planet, carries within it a story of that early chaos, a story that began long before the sun itself was born. The formation of our galaxy is a testament to the universe's patience and persistence. Billions of collisions, billions of years of accumulation, And yet from this tumult emerged order. The Milky Way is more than a collection of stars. It is a chronicle of cosmic history, a map of interactions both violent and delicate. Within its arms, stellar nurseries still hum with creation, echoing the processes that first sculpted its shape. Within its core, the supermassive black hole stands as both relic and anchor, a reminder that even in apparent calm, immense forces continue to shape the galaxy. And within this cradle of stars, life found a foothold. The Milky Way became the stage for planetary evolution, for chemistry and biology to unfold over eons, for consciousness to emerge and look back at the sky that birthed it. In tracing the galaxy's past, we trace the origins of everything we are and everything we might become. It is a story of collision and creation, of chaos giving way to order, of the infinite patience of the cosmos forging a home for life amid the vast, unending dark. At the Milky Way's center spins Sagittarius A star, a supermassive black hole with the mass of 4 million suns. Invisible, yet shaping everything we see. Its gravity dominates the orbits of stars near the galactic core, bending their paths into dizzying ellipses and accelerating them to speeds unimaginable elsewhere. While it swallows matter with a quiet appetite, it also orchestrates the movements of millions of stars, gas clouds, and cosmic dust, silently conducting the galaxy's intricate dance from the shadows. Sagittarius A star is a paradox, a region of infinite density surrounded by emptiness, where the laws of physics strain under extreme conditions. Light itself cannot escape, yet its presence is revealed in the motion of nearby stars, in the radiation emitted by gas as it spirals inward, and in the gravitational waves rippling through space. We have never seen it directly, and perhaps we never will. Instead, we perceive its influence, a subtle but absolute authority over the heart of our galaxy. The black hole's existence hints at the violent history of the Milky Way. Supermassive black holes likely grew from the collapse of massive primordial stars, merging over billions of years and accreting gas and stars as they grew. Sagittarius A star is the relic of that ancient chaos, a monument to the collisions and cosmic upheavals that shaped the galaxy. Around it, stars orbit in tight clusters, some completing an entire circuit in mere decades, tiny beacons tracing the invisible curvature of space-time. Their paths are records, cosmic footprints revealing the shape of an unseen dominion. Despite its immense power, Sagittarius A star is not a cosmic tyrant. Most of the time, it remains quiet, consuming only small amounts of gas and dust. But occasionally, it awakens, flaring with energy as it devours matter, sending streams of radiation into the surrounding galaxy. These events are rare, yet they remind us of the dynamic forces at work in the seemingly calm heart of the Milky Way. Life in our galactic neighborhood exists in delicate balance with this invisible giant, shaped by its presence even from thousands of light years away. Studying Sagittarius A star is more than a scientific endeavor. It is a confrontation with the extremes of reality. Here, space and time warp, relativity and quantum effects collide, and the familiar rules of the universe bend. It teaches us humility, showing how little we truly grasp about the depths of existence. Every orbiting star, every particle of gas drawn inward, is a lesson in the gravity of scales we can barely comprehend. The black hole is both a center and a mirror. It anchors the galaxy while reflecting the limits of human understanding, a reminder that much of the universe's majesty lies beyond direct observation. It shapes the Milky Way without ever being seen, a silent guardian of cosmic order and chaos. And in gazing toward the heart of our galaxy, we glimpse the paradox at the center of existence itself: power that is invisible, influence that is immeasurable, and beauty that resides in the darkness. Sagittarius A star is more than a black hole. It is the heart of the Milky Way, the axis around which billions of stars revolve, the keeper of history, and the eternal reminder that the universe often works in silence, shaping everything we see from beyond the reach of light. About 5 billion years ago, a cloud of dust collapsed into a newborn star, our Sun. It was the latest in a long line of stellar ancestors, carrying within it the ashes of supernovae. Those explosions, the deaths of earlier generations of stars, had forged the elements essential for life: carbon, oxygen, nitrogen, iron, and the countless heavier atoms that would one day become the foundation of planets, oceans, and living beings. The sun was both a child of the past and a herald of the future, a glowing beacon around which the story of our solar system would unfold. The cloud that birthed the sun was a swirling, turbulent mass of gas and dust. Gravity pulled it inward, compressing the center until nuclear fusion ignited, turning hydrogen into helium and releasing light and heat. Around this newborn star, a disk of material spun, rock, ice, and metal gradually coalescing into planetesimals, the seeds of worlds. Over millions of years, collisions and accretion built the planets, moons, and asteroids, sculpting a system in delicate balance. It was in this cauldron of creation that Earth emerged, cradled in the habitable zone, ready to nurture the chemistry of life. Every atom in our bodies tells this story. We are stardust in the most literal sense, composed of elements forged in the cores of ancient stars and scattered across space by supernovae. Life on Earth is the continuation of that cosmic process, a direct inheritance from stellar ancestors that lived and died billions of years before the sun was born. In a very real sense, we are the universe reflecting on itself, conscious products of countless stellar deaths and rebirths. The sun itself is a patient, steady star, unlike the volatile giants that preceded it. Its light and warmth drive the cycles of our planet, powering photosynthesis, regulating climate, and sustaining the rhythms of life. Without it, Earth would be a frozen, lifeless rock. Its presence is quiet, reliable, yet profound, a gentle, constant influence that has enabled the complex interplay of biology and geology that makes our world habitable. Yet the sun is also a reminder of impermanence. One day, billions of years from now, it will exhaust its hydrogen fuel, swell into a red giant, and reshape the solar system irrevocably. The planets will drift, the Earth's surface will transform, and the sun will shed its outer layers, leaving behind a white dwarf. Even stars have lifetimes, their brilliance measured against the immensity of cosmic time. The story of the sun is the story of possibility. It shows how chaos can produce order, how death can give rise to creation, and how the universe, through patient repetition, sets the stage for life. From a cloud of dust to the star that warms our planet, the sun is a luminous thread connecting us to the cosmos. It is a reminder that everything we are, everything we know, comes from a lineage of stars, and that the light bathing our world carries the memory of ancient explosions, the heartbeat of galaxies, and the promise of life. Around that infant sun, dust grains collided, merged, and grew into worlds. The leftovers became asteroids, comets, and moons, the debris of creation still drifting today. In the protoplanetary disk, a delicate balance of forces guided matter into ever larger clumps. Gravity pulled fragments together, while collisions broke some apart, shaping a process both chaotic and precise. Over millions of years, these tiny grains coalesced into planetesimals, which then combined into full-fledged planets, each carving its orbit and claiming its place in the nascent solar system. The inner regions, close to the sun's warmth, formed rocky worlds. Mercury, Venus, Earth, and Mars emerged as solid, terrestrial planets, their surfaces forged by intense collisions and volcanic activity. Farther out, beyond the frost line, gas giants like Jupiter and Saturn amassed thick envelopes of hydrogen and helium, their immense gravity shaping the orbits of smaller bodies and shepherding swarms of comets and asteroids. Uranus and Neptune formed on the outskirts, icy giants cloaked in methane, colder and slower to settle into their distant orbits. Each planet, in its formation, tells a story of both chance and inevitability, a result of cosmic laws and random collisions, of matter responding to gravity's persistent pull. The leftover debris of this creation did not vanish. Asteroids, rocky remnants of planet building, populate belts and scattered orbits, silent witnesses to a violent youth. Comets, Icy bodies carrying water and organic compounds traveled vast distances, occasionally delivering their cargo to young planets. Moons formed in collisions or were captured by gravity, becoming companions to their planets, influencing tides, climates, and rotational stability. Every fragment in this early solar system is a relic, a memory of processes that shaped not only the planets, but the potential for life itself. Earth, in particular, became the beneficiary of this delicate choreography. Collisions with planetesimals delivered water and essential elements, while the Moon, born of a giant impact, stabilized the planet's tilt and climate, creating conditions conducive to life. The stage was set for chemistry to take hold, for oceans to form, and for the first hints of biological processes to emerge. Without the precise arrangement of these cosmic events, Earth might have been barren, a cold rock drifting endlessly through space. The birth of the planets is a story of rhythm and repetition, of matter obeying gravity's quiet insistence, yet constantly shaped by chance encounters. It is a reminder that creation is rarely gentle. Worlds emerge from collisions, chaos, and destruction. And yet, from this turmoil, order arises, planets find stable orbits, systems settle into resonance, and the potential for life begins to take shape. Even today, the remnants of that era drift through the solar system, asteroids that might one day strike a planet, comets that flash across the sky. They are echoes of the birth of worlds, reminders that creation leaves traces, and that even in the quiet of space, the history of formation continues to whisper, shaping the universe one particle at a time. Third from the Sun, Earth found itself in the narrow band where water can flow freely. Not too hot, not too cold, a coincidence so perfect it borders on poetry. This habitable zone, neither scorched by solar fury nor frozen into lifeless ice, allowed oceans to form, clouds to drift, and rivers to carve valleys. The planet's position was the first of many delicate balances that would make life possible. A cosmic alignment that seems improbable in its precision, yet inevitable in its consequence. Earth's early years were turbulent. The young planet endured constant bombardment from asteroids and comets, each impact shaping the surface, delivering water and organic molecules, and occasionally sterilizing the landscape. Volcanoes erupted, releasing gases that formed a primitive atmosphere, while chemical reactions in the oceans began weaving the first threads of complexity. Life would emerge not as an inevitability, but as the outcome of countless interactions, each contingent on the planet's temperature, chemistry, and position within the solar system. Beyond distance from the Sun, Earth benefited from an extraordinary set of protective measures. Its magnetic field, born from a churning iron core, deflected solar winds that might otherwise have stripped away the atmosphere. The Moon, born from a titanic collision, stabilized the planet's axial tilt, regulating seasons and climate over eons. Even Jupiter, the massive gas giant in the outer solar system, acted as a cosmic shield, diverting some of the larger asteroids and comets that might have otherwise struck Earth with catastrophic force. Every factor, from orbital dynamics to planetary neighbors, played a part in this delicate choreography of habitability. In the oceans, chemistry quietly began its slow experiment. Molecules collided, bonded, and assembled into increasingly complex structures. The planet's mild temperatures allowed liquid water to persist, a solvent capable of nurturing the first metabolic reactions. Life began in whispers, microscopic and invisible, yet with the potential to transform the surface of the planet. These early organisms would eventually alter the atmosphere, draw down carbon, release oxygen, and pave the way for plants, animals, and ultimately, consciousness. The Goldilocks conditions are a testament to cosmic patience. Billions of years of gravitational pulls, orbital adjustments, and chemical reactions combined to create a single world where life could flourish. This is no mere accident. It is the intersection of countless probabilities, a fragile window in both space and time, where a star, a planet, and the laws of chemistry converge in a fleeting miracle. Earth's story is a reminder that life arises not in isolation, but in the precise interplay of forces across the cosmos. Distance from the Sun, atmospheric composition, magnetic protection, planetary companions, and ocean chemistry. All these elements together produce the possibility of life. In the vastness of space, where countless worlds remain barren, Earth stands as a rare jewel, a place where physics and chemistry conspired to create a stage upon which life could begin its enduring, intricate performance. The Goldilocks miracle is not just a description of habitability, it is the first chapter in the story of existence itself. It is the moment when the universe, in its infinite complexity, created the conditions necessary for consciousness to eventually look back and marvel at the cosmos that made it possible. Life began in the water, where chemistry met curiosity. Molecules danced, combined, and one day began to copy themselves. From that simple spark, evolution began its endless story. The oceans of early Earth were vast, warm, and rich with dissolved minerals, an alchemical playground where chemical reactions unfolded over millions of years. In tiny pockets of this primordial soup, molecules linked together, forming chains that could replicate, fold, and interact. Here, the first whispers of life stirred, invisible to the eye but profound in consequence. These earliest life forms were microscopic, fragile, and fleeting, yet their simplicity belied their potential. Each successful replication carried the blueprint for future generations, a record of survival written in molecules rather than words. Mutation and variation, the raw materials of evolution, appeared naturally, introducing diversity into these populations of molecular pioneers. In the vastness of the ocean, chance and chemistry combined to produce novelty, the very engine of life's creative force. Water itself played a critical role. It was both medium and protector, a solvent that allowed molecules to collide without immediate destruction, and a thermal buffer that stabilized temperatures. The tides, driven by the moon, stirred nutrients and energy across shallow seas, enhancing the likelihood of complex chemical interactions. Hydrothermal vents, deep beneath the ocean's surface, created gradients of heat and minerals, providing niches where life could gain a foothold even in the darkest corners of the planet. In these dynamic environments, the first cells were born, tiny vessels of self-replicating chemistry, carrying within them the potential to adapt, endure, and multiply. From this simple beginning, evolution began to explore the possibilities of life. Natural selection favored structures that were more stable, more efficient, more capable of surviving in their environment. Over eons, these primitive cells diversified, forming networks of metabolism, communication, and reproduction. Each generation carried a record of the past, but also the capacity to innovate, to experiment with new forms, to push the boundaries of what was possible. Life, in its essence, became both a historian and a pioneer, preserving what worked and probing the unknown. The ocean that dreamed did more than nurture molecules. It became the cradle of potential. Within its depths, the building blocks of DNA, RNA, and proteins began to assemble, creating the machinery that would allow for greater complexity. It was here that life learned to harness energy, process information, and eventually organize into multicellular organisms. The oceans, vast and patient, witnessed countless experiments in survival, discarding failure and celebrating persistence. Life's origin in water is a story of balance, chaos tempered by order, randomness guided by laws of chemistry, and simplicity evolving into complexity. From that first self-replicating molecule, an unbroken thread connects the primordial oceans to every organism alive today, including us. In the silent, endless expanse of early seas, the first dream of life emerged, a dream that would ripple through billions of years, shaping Earth and all who inhabit it. Cyanobacteria turned sunlight into oxygen, filling the skies and reshaping the world. Every breath you take is borrowed from the ancient rhythm of those microscopic ancestors. For billions of years, life on Earth had been content to exist in the quiet, invisible shadows of the oceans. Simple, self-replicating cells thrived in chemical pools and shallow seas, extracting energy from organic molecules and leaving little trace beyond their presence. Then, something extraordinary happened. A new form of metabolism emerged, one that could capture the energy of the sun itself and, in the process, release oxygen as a byproduct. This innovation was subtle yet revolutionary. Cyanobacteria, with their internal machinery for photosynthesis, began to transform the very chemistry of the planet. Oxygen, once a scarce and reactive gas, began accumulating in the atmosphere. At first, it reacted with iron and other elements, rusting the oceans and seafloor in a slow, chemical drama. But eventually, the oxygen persisted, building up in the skies, creating an environment that would make more complex life possible. The planet's first great transformation had begun, the rise of an oxygen-rich world. The Great Oxidation Event, billions of years ago, was both a crisis and an opportunity. For anaerobic organisms, creatures adapted to life without oxygen, this new gas was deadly, a poison that threatened their existence. Many vanished or retreated to isolated niches. Yet for life capable of harnessing this oxygen, a new energy frontier opened. Aerobic respiration allowed organisms to extract far more energy from nutrients than anaerobic processes ever could, enabling growth, complexity, and eventually multicellular life. The tiny cyanobacteria had rewritten the rules of biology and the chemistry of the planet, setting the stage for everything that would follow. Oxygen's rise also changed the oceans and the land. The once reducing seas gradually became oxidizing environments, paving the way for new minerals to form and altering the cycles of carbon, nitrogen, and sulfur. Atmospheric changes cooled and stabilized the climate over time, and eventually, the accumulation of oxygen would lead to the formation of the ozone layer, shielding the planet from harmful ultraviolet radiation. These interconnected processes demonstrate the profound influence of these microscopic organisms, the smallest actors with the largest consequences. Cyanobacteria remind us that life is not a passive passenger on Earth, but an active participant in shaping its environment. Through photosynthesis, these organisms became the planet's lungs, the invisible breathers that altered chemistry, climate, and the potential for evolution. Every leaf that captures sunlight today, every plankton drifting in the ocean, continues this legacy, tracing an unbroken lineage to the first cells that learned to convert light into oxygen. The breath of the planet is more than a biological process. It is a narrative of transformation. It tells of how simplicity gave rise to complexity, how life's ingenuity reshaped an entire world, and how the interplay between organisms and their environment sets the stage for future possibilities. Oxygen became both a weapon and a tool, a challenge for some and a catalyst for others. And in this balance, the Earth became a stage where evolution could explore the extraordinary, eventually producing the vast diversity of life we see today. In every inhalation, in every gust of wind, the legacy of those tiny cyanobacteria persists. They taught the planet to breathe, to sustain complexity, and to create a chemistry that allows life to flourish. The air we rely on, the sky we see, and the very chemistry of our bodies are all gifts from these ancient architects who, in the quiet depths of primordial seas, sparked a revolution invisible to the eye but eternal in consequence. From single cells rose giants, creatures of unimaginable form. Dinosaurs thundered across the continents, rulers of a world still learning to dream. Life had been experimenting for hundreds of millions of years, slowly building complexity from the microscopic to the macroscopic, from simple multicellular organisms to sprawling ecosystems. By the Mesozoic era, evolution had sculpted forms that seemed almost impossible. Towering sauropods whose necks stretched to the treetops, swift predators honed for speed and cunning, armored beasts that carried their own defenses like walking fortresses. These monsters were the embodiment of life's creativity, unbound by limitations we could imagine. The Earth itself was a co-conspirator in this grand design. Vast forests of ferns, cycads, and conifers provided both shelter and sustenance. Rivers carved fertile valleys, and seas teemed with life forms that mirrored and influenced terrestrial evolution. Volcanoes reshaped landscapes, and shifting continents altered climates, forcing creatures to adapt, migrate, or vanish. Life and planet were in constant dialogue, a partnership of survival and transformation, each influencing the other in a complex rhythm that spanned millions of years. Dinosaurs were not the only marvels of this era. Gigantic flying reptiles ruled the skies, while marine reptiles dominated the oceans. Insects swarmed in staggering numbers and sizes, some with wingspans that seem unimaginable today. This was a period when life explored extremes, testing the limits of anatomy, physiology, and behavior. Predators grew faster, stronger, and more cunning. Herbivores developed armor, spikes, and extraordinary defensive strategies. The planet had become a living laboratory, experimenting with form, function, and survival on a scale both awe-inspiring and terrifying. Yet the age of monsters was not defined solely by size or ferocity. Evolution was also crafting subtler marvels: the first feathers, the early ancestors of birds, and the beginnings of warm-bloodedness in some lineages. Life was innovating in ways that would echo into the future, laying foundations for species that could survive cataclysm, climate change, and eventual extinction. Every roar, every footfall, every hunt and evasion was part of a grand experiment in adaptation and resilience. The dominance of dinosaurs, while breathtaking, was also fragile. Shifts in climate, volcanic activity, and the eventual catastrophic asteroid strike would remind us that even the largest and most powerful creatures are subject to forces beyond their control. Extinction is as much a part of life's narrative as creation, and the Age of Monsters was no exception. Yet in their reign, these giants defined an era, shaping ecosystems and influencing the evolutionary trajectory of life for millions of years to come. In their shadows, the seeds of the modern world were quietly forming. Mammals, birds, and plants were diversifying, waiting for the moment when the monsters would vanish and new forms would rise. The Earth during this era was alive with motion, drama, and invention. Every roar of a predator, every rustle of a massive herbivore, every ripple of life across oceans and skies was part of the ongoing story of evolution, a story that began in the primordial oceans and would continue through the rise and fall of worlds. The Age of Monsters reminds us of life's ambition and audacity. It tells us that the Earth has always been a place of extremes, a stage where biology experiments with scale, power, and complexity. In imagining those giants walking the continents, we glimpse the extraordinary creativity of evolution, a force that transforms the microscopic spark of life into the titanic spectacles that once ruled the planet. A rock from space ended an era. Yet from extinction came opportunity. Mammals, once small and hidden, began to rise. About 66 million years ago, a colossal asteroid struck the Earth, unleashing fire, shockwaves, and tsunamis that reshaped the planet in an instant. The skies darkened, temperatures plummeted, and life that had dominated for tens of millions of years, the dinosaurs, vanished from most of the Earth's surface. In that catastrophic moment, the rules of survival were rewritten, and the stage for a new cast of creatures was set. For the tiny mammals that had existed in the shadows, the asteroid's devastation was paradoxically liberating. No longer overshadowed by colossal reptiles, these small, adaptable creatures found open ecological niches waiting for them. Forests regrew, climate stabilized, and the rich diversity of life returned in a new form. Evolution, which had been constrained for so long, now had the freedom to explore new possibilities. It was a moment of radical opportunity, a cosmic reset that would eventually lead to the Age of Mammals and, billions of years later, the emergence of humanity. The survivors were diverse and resourceful. Early mammals were small, nocturnal, and often insectivorous, but they carried within them the potential for innovation and adaptation. Some began climbing trees, exploring new heights. Others burrowed underground, developing ways to thrive in hidden spaces. Over millions of years, these incremental adaptations accumulated. Limbs elongated, brains grew more complex, and behaviors diversified. The shadowed creatures of the past slowly became the rulers of the future, proving that survival often favors persistence, cunning, and adaptability over size and brute force. The aftermath of the asteroid strike also reshaped the planet itself. Volcanic activity, shifting continents, and changing climates created an environment in constant flux. Mammals were forced to innovate, evolving new strategies for feeding, avoiding predators, and navigating their world. Forests and grasslands expanded, providing fresh opportunities for exploration and specialization. River systems carved fertile valleys, mountains rose and fell, and deserts spread, all shaping the evolutionary pressures that guided the rise of mammals. Nature, once again, was a patient sculptor, molding life over millions of years with relentless precision. This era demonstrates the paradoxical relationship between catastrophe and creation. Destruction clears the way for innovation. The fall of one dominant group allows others to flourish. Mammals, once marginalized, diversified into forms unimaginable during the reign of the dinosaurs: burrowers, climbers, swimmers, and eventually predators and grazers that would dominate the planet's ecosystems. The extinction event did not merely wipe the slate clean, it created the conditions necessary for new life to flourish, highlighting the unpredictable interplay between chance and necessity in the history of life. The night the sky fell serves as both a warning and a lesson. It reminds us of life's fragility, yet it also celebrates resilience. From devastation came growth. From darkness emerged opportunity. The rise of mammals would eventually lead to intelligence, consciousness, and the capacity to reflect on the story of life itself. In the shadow of catastrophe, the tiny, hidden creatures began their quiet ascent, shaping a world that would one day hold forests, oceans, cities, and civilizations. In the end, the asteroid did not just end an era, it began another. It cleared space for life to innovate, adapt, and reach toward the extraordinary. The tiny mammals that emerged from this chaos carried within them the promise of all that was to come, proving that evolution is as much about timing and opportunity as it is about strength and survival. Somewhere in the neural storm of early humans, the universe became aware of itself. Firelight flickered against cave walls as thought met imagination. In those first moments of reflection, awareness was both fragile and infinite. A mind capable of memory, anticipation, and planning began to emerge, bridging instinct with insight. The human brain, a dense web of neurons and synapses, sparked in ways that allowed early humans to not only survive, but to question, to imagine, and to create. Tools were born from curiosity. Stones shaped into sharp edges, sticks used to reach and prod, simple inventions that extended the senses and amplified the body's abilities. Language began as grunts and gestures, then evolved into shared symbols, stories, and songs. In these early interactions, culture began to take shape, a collective memory that could outlive an individual, carrying knowledge, strategies, and myths across generations. The fire that warmed the body also illuminated the mind, enabling planning, cooperation, and the first glimmers of abstract thought. Imagination, perhaps the defining trait of our species, allowed humans to see beyond the immediate, to conceive of what did not yet exist. Early art, etched in stone or painted on cave walls, was a dialogue with the unseen. Animals, hunting scenes, and abstract patterns were both records and rituals, bridging the tangible world with the invisible. In marking their environment, humans were marking themselves, asserting consciousness in a universe that had, until then, been indifferent. Memory and foresight intertwined, giving rise to strategies and social structures. Groups organized, hunting and gathering together, communicating danger, opportunity, and knowledge. Collaboration became a survival advantage, while empathy and imagination shaped the bonds between individuals. These early societies, though small and fragile, laid the foundation for language, trade, and culture. Each spark of thought added to the collective awareness, a growing tapestry of consciousness that would eventually encompass the planet. Fire itself became a symbol and a tool, transforming daily life. It extended the day, warded off predators, cooked food, and brought warmth. But its flickering light also drew humans together, creating shared spaces where stories were told and plans were made. Around those flames, imagination and memory coalesced, and humans began to perceive not only the world around them, but the worlds within them. In the quiet hours, the mind could wander through possibilities, inventing solutions, myths, and futures. The emergence of consciousness was more than biology. It was a cosmic event. Through neural circuits and synaptic sparks, the universe found a way to look back at itself. In the eyes of early humans, in their curiosity and wonder, the cosmos glimpsed its own story, unfolding across eons, from stardust to life, from simple cells to self-aware minds. This awareness, tentative yet profound, set the stage for art, science, philosophy, and the countless endeavors that would attempt to understand existence itself. The sparks of consciousness remind us that life is not just a sequence of chemical reactions or genetic mutations. It is an awakening, a dialogue between mind and universe, a recognition that the cosmos can perceive and reflect on its own story. Firelight on cave walls, early tools, and shared songs were the first instruments of this reflection. Small gestures that echo across time, tracing a path from ancient neurons to the minds that now read and imagine these words. In those flickering moments, the universe became conscious, and from that spark, everything we call human would grow, a mind capable of wonder, creativity, and the endless pursuit of understanding. We looked up, built instruments of glass and metal, and realized the stars were suns, each perhaps with its own worlds. The cosmos had multiplied. Humanity, once confined to the rhythms of a single planet, began to measure, calculate, and map the heavens. The night sky, a tapestry of light, became both a challenge and an inspiration. Telescopes, lenses polished to perfection, and later instruments detecting invisible waves of energy revealed that the universe was far larger and more intricate than anyone had imagined. The Milky Way, once the entirety of human perception, was now only a single island of light in a vast cosmic ocean. Other galaxies, billions of them, stretched across unimaginable distances, each containing billions of stars. The concept of space expanded. Human minds struggled to grasp the immensity. Light from distant galaxies carried the echoes of ancient epochs, allowing us to look back in time, to see the universe as it had been billions of years before our sun or even our species existed. Each discovery revealed a cosmos alive with history, a stage for phenomena both violent and sublime. Instruments became extensions of curiosity. Spectroscopes decoded the composition of stars, revealing elements forged in distant furnaces. Observatories, perched atop mountains or launched into orbit, pierced the atmosphere's veil, bringing the invisible into focus. Humanity began to see the fingerprints of gravity, the whispers of light from the farthest reaches, and the subtle glow of cosmic microwave background radiation, the afterglow of creation itself. Every new measurement was a revelation, a step closer to understanding our place in the universe. This era also expanded the scale of imagination. The notion that planets could orbit other stars, that life might exist beyond Earth, moved from speculation to serious scientific inquiry. The cosmos was no longer a static backdrop for human drama. It was a living, dynamic expanse, filled with possibility. Comets, asteroids, and distant exoplanets became more than curiosities. They were potential clues to the processes that had shaped our own world, and perhaps hints of life elsewhere. Human thought stretched to encompass light years, supernovae, black holes, and galaxies spiraling silently in the dark. The age of discovery was not limited to observation alone. It reshaped philosophy and understanding. Humanity began to see itself as both infinitesimal and extraordinary. Infinitesimal because the universe was vast beyond comprehension. Extraordinary because we had the capacity to perceive it, to question it, and to explore it. Knowledge became a bridge between the finite experience of our senses and the infinite reality of the cosmos. Exploration, both physical and intellectual, became a defining trait of our species. We launched satellites to orbit Earth, probes to distant planets, and eventually telescopes to the edge of the observable universe. We began to translate photons that had traveled billions of years into images and data, tracing the history of the cosmos and, by extension, the story of our own existence. The universe multiplied in our understanding, each discovery revealing layers of complexity, beauty, and mystery. The age of discovery reminds us that curiosity is an extension of consciousness itself. It is the mind reaching outward, seeking to understand the forces that shaped galaxies, stars, and planets. Humanity became not only a witness to the universe, but a participant in its story, learning to decode the messages carried across time and space. In the end, to look up and discover is to connect, to realize that the cosmos is not distant or separate. It is entwined with the human mind, forever inviting us to wonder, question, and dream. Telescopes like Hubble and Webb became extensions of our own sight, revealing galaxies older than imagination, planets more alien than dreams. Humanity, once bound to Earth's surface, had learned to pierce the veil of our atmosphere, to reach beyond the limits of our eyes and sense the cosmos in unprecedented ways. From orbiting observatories, photons that had traveled billions of years finally met our instruments, carrying with them the story of creation, evolution, and the vast structures that dominate the universe. Through Hubble, the universe revealed its grandeur in unprecedented detail. Spiral galaxies, elliptical giants, and irregular formations displayed their shapes and colors, each a record of cosmic history. Nebulae glowed with the light of newborn stars, while supernova remnants whispered of destruction and renewal. The telescope became a bridge between human curiosity and the infinite, allowing us to measure distances, calculate ages, and witness phenomena that had unfolded long before Earth existed. Every image was a revelation, each observation a window into the past and a lens on the processes that shaped everything we know. Webb expanded this vision, reaching into infrared wavelengths that had been hidden from prior instruments. It allowed us to glimpse the first galaxies, the faintest stars, and the chemistry of distant exoplanets. Planets around other stars, once the domain of speculation, now showed atmospheres, hints of water, and the possibility of life. The cosmos became tangible, a vast laboratory of light, matter, and energy, where every observation challenged assumptions and expanded imagination. With Webb, we could see not just the structures but the building blocks, the very ingredients that formed stars, planets, and potentially life itself. These telescopes are more than machines, they are extensions of human consciousness. They transform photons into meaning, translating the silent language of the universe into knowledge we can grasp. They reveal patterns and structures invisible to our senses, allowing us to trace the evolution of galaxies, the cycles of star formation, and the interactions of gravity across unimaginable scales. Each observation connects us to the universe's deep history, reminding us that we are participants in a story that stretches back 13 billion years. The eye in the sky also reshapes perspective. By observing distant galaxies and exoplanets, we confront the immensity of space and the humility of our own existence. Yet this knowledge inspires awe rather than despair. It demonstrates that humans, through ingenuity and curiosity, can touch the cosmos, can understand its rhythms, and can glimpse the processes that have unfolded long before we appeared. In the faint light of a distant quasar or the spiral arms of a galaxy billions of light years away, we see echoes of the universe's youth, a reflection of the forces that shaped our own solar system, our own planet, and our own lives. These observatories are the first step toward deeper exploration. They not only reveal the universe but guide our future, identifying planets to study, regions to explore, and questions to ask. They teach patience, precision, and the humility to interpret subtle signals across vast expanses of space. The universe, once mysterious and inaccessible, now opens itself to inquiry, revealing that observation is a form of participation, a dialogue between human minds and the cosmos. The eye in the sky reminds us that curiosity can extend beyond our bodies and our lifetimes. Through Hubble and Webb, humanity reaches farther than ever before, translating faint light into knowledge, wonder, and possibility. Each photon captured is a story, a fragment of cosmic memory, a testament to the universe's grandeur, and a reflection of our unending desire to understand the world beyond our own small sphere. In looking outward, we also look inward, discovering the reach of our own imagination and the depth of our connection to the cosmos. When Voyager turned its camera back toward Earth, it saw a speck suspended in a sunbeam. Everything we've ever loved, every story ever told, contained in that single pixel. That tiny point of light, barely distinguishable against the vastness of space, captured the fragility and wonder of our home. From billions of kilometers away, the Earth appeared as nothing more than a pale blue dot, a world adrift in an immense cosmic ocean. Yet within that dot exists the entirety of human history, every moment of joy, sorrow, discovery, and imagination. The image reminds us of perspective. The continents, oceans, and skies we take for granted are just a tiny fragment of the universe. The conflicts, ambitions, and triumphs of humanity are dwarfed by the scale of space, yet they are no less meaningful within this fragile sphere. Our achievements, failures, loves, and losses all unfold on this single, suspended world. Voyager's gaze makes it clear the universe does not single us out. We are one small part of a vast, indifferent cosmos. And yet, our capacity to observe, to reflect, and to create gives this tiny world infinite significance. Carl Sagan, who framed this image for the world, described it as a humbling reminder of our place in the cosmos. Nations, borders, and divisions dissolve when seen from such a distance. The pale blue dot emphasizes our shared destiny, the common ground of life on Earth. It calls for humility, compassion, and stewardship. For the planet's preservation is not optional, it is necessary. Every species, every ecosystem, every river and mountain is part of the delicate balance that makes life possible. Viewed from Voyager's perspective, the Earth is not just home, it is a singular oasis of complexity, a miracle suspended in the void. The photograph also evokes wonder. That faint dot, illuminated by sunlight, carries echoes of billions of years of evolution, from the first cells in the oceans to the neural storms of human consciousness. It is the endpoint of cosmic history and the starting point for countless journeys of thought, exploration, and imagination. Within that single pixel exists the story of galaxies, stars, planets, and life itself. A narrative written in the language of atoms, photons, and time. In contemplating the pale blue dot, we confront both humility and possibility. We are small, but our capacity for understanding, empathy, and creativity allows us to perceive the universe and reflect upon our own existence. From this perspective, the Earth becomes a symbol of resilience, curiosity, and hope. It reminds us that our most profound achievements, art, science, philosophy, love, are not diminished by scale but are amplified by our awareness of the vastness around us. Voyager's image is also a call to exploration. It challenges us to continue reaching outward, to learn, to travel, and to dream. The pale blue dot may be tiny in the cosmic expanse, but it is ours, and it is precious. In its fragile light, we see the unity of all life, the brevity of individual existence, and the enduring significance of human consciousness. It is a reminder that, for all its smallness, our world contains everything that matters to us, the sum of memory, experience, and imagination, suspended in a sunbeam, spinning through the endless dark. The pale blue dot is not just a photograph. It is a meditation on existence. It shows us who we are, where we come from, and the wonder of being alive in a universe that is at once vast, indifferent, and beautiful. In that single pixel, humanity glimpses itself, fragile yet extraordinary, and the infinite possibilities that lie ahead. Equations are the poetry of reality. From Newton's gravity to Einstein's relativity, they reveal a hidden order beneath the chaos. They translate the universe's rhythms into language we can understand, a symbolic bridge between human thought and cosmic truth. When Newton described the motion of planets, he revealed patterns invisible to the eye, forces that bound stars, planets, and moons into predictable paths. Gravity became more than a mysterious pull. It became a principle that could explain orbits, tides, and the rise and fall of celestial bodies with astonishing precision. Yet Newton was only the beginning. Einstein, centuries later, reframed our understanding of space and time. Gravity was no longer a simple force acting at a distance. It was the curvature of space-time itself, shaped by mass and energy. Equations described black holes, the bending of light, and the expansion of the universe. Suddenly, we could see how massive stars collapse, how galaxies swirl, and how light itself can be stretched across billions of years and distances. Mathematics had become a telescope of the mind, revealing the universe in ways no instrument could. Equations are also a window into the smallest scales of existence. Quantum mechanics, with its probabilistic rules and wave functions, describes a world that defies intuition, where particles can exist in multiple states at once, and uncertainty is fundamental. Schrödinger, Heisenberg, and Dirac gave us the language to understand electrons, photons, and the forces that govern chemistry and life itself. From the cosmic scale of galaxies to the subatomic world, mathematics is the thread that unites disparate phenomena into a coherent tapestry. Beyond description, equations predict. They allow us to explore realities we cannot yet see. Einstein predicted gravitational waves a century before we detected them, and Dirac's equations anticipated antimatter long before it was observed. Through the symbolic precision of mathematics, we glimpse the universe not only as it is, but as it could be. Equations map possibilities, constrain probabilities, and illuminate the consequences of cosmic events. From supernovae to the dance of binary stars. Yet mathematics is not merely utilitarian, it is profoundly beautiful. Euler's identity, the elegance of pi, the symmetry of group theory, all hint at a universe that is orderly, harmonious, and comprehensible. The laws of nature, expressed through symbols and numbers, reveal patterns that transcend human culture, connecting intellect and intuition, imagination, and reality. In their symmetry and elegance, equations evoke awe akin to gazing at the night sky or the intricate spiral of a galaxy. Mathematics also serves as a mirror of human thought. It is the tool through which we comprehend infinity, model chaos, and formalize the structure of reality. Through equations, we translate sensory experience into universal principles, converting observation into insight. They are proof that consciousness can perceive the cosmos not only emotionally or intuitively, but with precision and rigor. The math that describes everything reminds us that the universe is not only vast and mysterious, it is knowable. Through numbers, symbols, and logic, we can touch the structure of reality, predict phenomena across space and time, and uncover the hidden symmetries that govern existence. In equations, the cosmos speaks a language of logic and beauty, and humanity has learned to listen. At the smallest scales, reality flickers like candlelight. Particles exist everywhere and nowhere, collapsing only when we look. The universe, it seems, depends on attention. Quantum mechanics reveals a world profoundly different from our everyday experience. A place where certainty dissolves into probability and observation shapes outcome. Electrons orbit nuclei, not as fixed points but as clouds of possibility, vibrating in patterns dictated by mathematical rules and chance. Light behaves as both particle and wave, matter and energy intertwining in ways that defy intuition. In this strange domain, the classical rules of cause and effect bend. A particle can tunnel through a barrier it should not surmount, exist in multiple states simultaneously. or communicate correlations across vast distances, a phenomenon Einstein famously called spooky action at a distance. Space and time, once assumed to be continuous and absolute, are revealed as malleable, intertwined with energy and probability. The quantum world is not a backdrop to the universe. It is the foundation of reality, underlying every star, planet, and living cell. Observation becomes a profound act. The mere act of measuring a quantum system forces it into a definite state, collapsing waves of probability into a singular outcome. In some interpretations, reality itself is not fixed until it is observed. This challenges our notions of objectivity, suggesting that consciousness and awareness may play a role in shaping the universe, or at least in the way we experience it. Particles do not simply exist, they participate in a dance with the observer, revealing that the cosmos is not merely external, but relational, a web of interactions across scales. Quantum phenomena are not merely theoretical curiosities, they underpin everything we know. Semiconductors, lasers, and magnetic resonance imaging all rely on quantum principles. The chemistry that builds DNA, proteins, and the molecules of life itself arises from the behavior of electrons governed by quantum rules. Even the fusion that powers stars is dictated by tunneling probabilities. From the smallest quark to the brightest supernova, the universe is a quantum tapestry, a delicate interplay of uncertainty and law. The poetic nature of quantum mechanics lies in its ambiguity. Reality is both deterministic and probabilistic, ordered yet unpredictable. Waves interfere, particles entangle, and the universe reveals a subtle, whispering logic that is accessible only through mathematics and careful observation. It teaches patience, humility, and awe, showing that the cosmos is far stranger than classical imagination allows, and yet astonishingly elegant in its underlying principles. At its heart, the quantum whisper is a reminder of connection. Every observation links observer and observed. Every particle, field, or photon participates in a cosmic dialogue. It challenges the assumption that the universe exists independently of consciousness, inviting us to reconsider the nature of existence itself. In the flicker of a photon, in the tunneling of an electron, in the entanglement across light years, the universe communicates in subtle, intricate ways, reminding us that mystery and comprehension are intertwined. In contemplating the quantum realm, we glimpse the paradoxical nature of reality, fragile yet enduring, uncertain yet structured, invisible yet foundational. The quantum whisper teaches that the universe is alive in its own silent way, responsive, dynamic, and endlessly surprising. At the smallest scales, the cosmos reveals itself not as a static stage, but as a living, vibrating interplay of possibility. A candle flickering in the dark, waiting for attention to illuminate its hidden dance. Atoms are the universe's alphabet: hydrogen, helium, carbon, oxygen. From these few letters, nature writes everything: stars, stones, oceans, you. Each atom carries a history, forged in the furnaces of stars, traveling across eons and space to assemble into the matter we see around us. Hydrogen, the simplest and most abundant, fueled the first stars. Helium, a product of those fiery crucibles, joined with hydrogen to create light, warmth, and the cosmic chemistry that would seed planets. Carbon, versatile and complex, forms the backbone of life itself, while oxygen combines with hydrogen to sculpt oceans and breathe life into worlds. In every object, every organism, every particle of matter, there is a story written in atomic language. Stars ignite through the fusion of hydrogen, producing energy that travels across space as light. Supernovae scatter heavier elements, iron, calcium, silicon, into the cosmos, providing the raw materials for planets, for minerals, for the chemistry of life. The atoms that compose our bodies were once part of ancient stars, cosmic travelers that endured explosions, drifted through interstellar space, and eventually found their way into the building blocks of life. In a very literal sense, we are made of stardust. This symphony of atoms is governed by fundamental forces and precise rules. creating structure from chaos. Electrons orbit nuclei in predictable patterns, forming molecules and compounds with infinite variety. Chemistry becomes the grammar of nature, dictating how atoms combine to build rocks, water, proteins, and DNA. Even the air we breathe is a dynamic composition of oxygen and nitrogen, constantly interacting with life, oceans, and the climate, a subtle rhythm that sustains every living thing. Atoms are also timeless narrators. They move through cycles of birth, transformation, and decay, connecting the smallest scales with the grandest structures. A hydrogen atom born in the Big Bang can pass through a star, drift in interstellar clouds, become part of a planet, and enter the cells of a living organism. In this way, every atom is both ancient and ever-present, a messenger linking the origin of the cosmos to the present moment. Their interactions are the verses of a universal poem, each combination, collision, and bond, a note in the eternal music of creation. The atomic symphony extends beyond Earth. Hydrogen and helium dominate the stars, carbon traces the life we imagine on distant worlds, and oxygen shapes atmospheres across the cosmos. From the crust of planets to the cores of stars, the same elements play out variations on the same themes, proving that the universe writes in a common language. It is a symphony that resonates across scales, quarks, nuclei, molecules, planets, galaxies, each movement harmonizing with the others in a dance that has persisted since the dawn of time. In contemplating the atomic symphony, we see the unity of existence. Stars and stones, oceans and organisms, humans and planets, all emerge from the same alphabet. Understanding atoms is to understand the fundamental poetry of the cosmos, the rules and rhythms that allow complexity to arise from simplicity, order from apparent chaos. It reminds us that the universe is not only vast in scale but elegant in construction, a place where the tiniest components carry the weight of history and the potential for future creation. The atomic symphony is both a scientific and poetic truth. In every breath, in every heartbeat, in every star that shines, the atoms that compose us and our surroundings sing their quiet, eternal song. From the primordial hydrogen of the Big Bang to the complex molecules of life, this symphony is ongoing, ever-changing, and profoundly beautiful, a reminder that the universe communicates through the very matter that makes us who we are. Time flows, but not evenly. Near black holes it slows, at light speed it stops. Every moment you experience is a local illusion, stitched to a vast cosmic rhythm. Our intuition, grounded on the steady ticking of clocks and the rising and setting of the sun, deceives us. The universe tells a different story, a story in which time is flexible, malleable, and intimately connected with space and gravity. In the presence of massive objects, time stretches and warps, slowing the march of seconds, minutes, and hours. Near the event horizon of a black hole, time itself seems to freeze, a frozen river of moments, while light and matter twist in gravity's grip. Einstein revealed this truth with his theory of relativity. Time is not absolute. It is part of the fabric of space-time, interwoven with the three dimensions of space. Motion, mass, and energy dictate its flow. A clock aboard a speeding spaceship ticks differently from one resting on Earth, and every orbit, every journey across a gravitational gradient subtly alters the passage of time. For astronauts, explorers, and particles alike, experience becomes relative, shaped by velocity and gravity, showing that the universe's rhythm is more intricate than any human imagination can fully grasp. The dance of time is everywhere. Cosmic clocks, pulsars spinning with near-perfect precision, tick in synchronicity across light years, while the expansion of the universe stretches space and the intervals between events. Light from distant galaxies carries the imprint of billions of years, letting us witness history as if traveling backward, seeing stars form, galaxies collide, and supernovae erupt long before humans walked the Earth. In a very real sense, the past is still alive in the present, encoded in photons racing across the void. Time also shapes life on Earth. Evolution unfolds over eons, rivers carve landscapes, Mountains rise and erode, glaciers advance and retreat. Even the rhythms of our own bodies, heartbeats, circadian cycles, and the cellular processes that sustain life are tied to the passage of time, a local reflection of a cosmic flow. What feels immediate and urgent to us is only a fraction of the universe's vast temporal landscape. Near black holes, in the vast emptiness of intergalactic space, and across the light years between galaxies, the elasticity of time becomes tangible in thought experiments and calculations. Travelers moving close to the speed of light would return home to find generations have passed while they barely aged. In the curvature of space-time around massive objects, moments stretch, slow, and fold upon themselves. These are not just theoretical musings, they are real consequences of the universe's structure, reminders that our experience is a local perspective, limited and subjective. The dance of time is also a meditation on impermanence and continuity. Every second is unique, yet every moment is part of an unbroken cosmic flow. Time carries the echoes of the Big Bang, the formation of stars, and the rise of civilizations. It connects the quantum flicker of particles to the spiraling arms of galaxies. In recognizing this, we see that life, memory, and history exist not in isolation, but as threads in the grand tapestry of the cosmos. Time, then, is both flexible and absolute, local and universal, fleeting and eternal. Every heartbeat, every thought, every moment is part of a rhythm that began before us and will continue long after. In the universe's vast orchestra, we are dancers, moving with a tempo defined not by clocks, but by the very curvature of space, the gravity of stars, and the relentless expansion of existence itself. Space and time aren't separate, they are one fabric, warped by mass and motion. Every step you take slightly curves the universe around you. Einstein's insight into space-time revealed a profound truth. The cosmos is not a static backdrop, but a dynamic stage, shaped by the presence of matter and energy. Planets orbit stars not because they are pulled invisibly across empty voids, but because mass bends the fabric of space-time itself, guiding their paths along invisible curves, tracing arcs dictated by geometry and gravity. Even the tiniest object contributes to this bending. Your own body, by virtue of mass, distorts the space immediately around it, imperceptibly shaping the flow of time and motion. On cosmic scales, these distortions grow immense. Black holes warp space-time to extremes, creating regions where time nearly halts. Light curves in impossible arcs, and the very concept of here and there loses meaning. Galaxies spiral along gravitational scaffolding. Clusters of matter interact over millions of light years, and the universe itself expands, stretching the fabric that binds everything together. This bending fabric is not merely a mathematical abstraction, it is tangible, observable, and essential. Gravitational lensing allows us to see light from galaxies billions of light years away, bent and magnified as it passes massive objects. Pulsars and stars trace paths dictated by the curvature of space-time. Even the rhythmic expansion of the cosmos, accelerating under dark energy, is an expression of how this unified fabric responds to energy and matter. In every corner of the universe, the curvature of space-time shapes the evolution of structures, the movement of stars, and the dance of galaxies. Mass and motion weave a tapestry that is simultaneously delicate and vast. A neutron star, compressed into the size of a city, bends space so sharply that light itself circles it. Supermassive black holes, millions or billions of times the mass of the Sun, sculpt galaxies around them, influencing formation, motion, and life itself. Even ripples in space-time, gravitational waves, travel across the universe, echoes of collisions and cataclysms that allow us to hear the cosmos in ways we could not imagine a century ago. The fabric that bends reminds us that the universe is profoundly interconnected. Nothing exists in isolation. Every particle, every star, every planet interacts with and influences the space-time around it. Motion, energy, and gravity are threads in a vast, invisible quilt, binding the cosmos into a coherent, dynamic whole. When we walk across the Earth, launch satellites into orbit, or send probes into the outer solar system, we are interacting with this fabric, tracing curves dictated by the mass of our planet and the Sun. This insight also reshapes our understanding of perspective. Distances, durations, and even the sequence of events are not absolute. They depend on the observer's location and motion relative to the warped fabric. Time slows near massive bodies, paths curve around unseen geometries, and light takes the shortest route through a bent, four-dimensional landscape. The universe is not a stage we inhabit. It is a living, bending structure that responds to the energy, mass, and motion within it. In contemplating the bending of space-time, we glimpse the elegance and subtlety of the cosmos. It is a realm where geometry becomes destiny, where every object participates in shaping the whole, and where even the smallest actions ripple across the unseen fabric. The fabric that bends is a reminder that we are part of this vast, interconnected dance, living on a stage woven of space, time, and gravity, forever tracing arcs in a universe that curves beneath our feet. When massive stars collapse, they explode as supernovae, brief, brilliant deaths that scatter the elements of life into the cosmos. These cataclysmic events are the universe's most magnificent pyrotechnics, a fleeting blaze that outshines entire galaxies for a moment in time. Yet beyond their dazzling display lies a profound purpose. They forge and distribute the very atoms that form planets, oceans, and the molecules of life itself. Every carbon in your body, every calcium in your bones, every iron atom in your blood was once part of a star that lived, burned, and died in spectacular brilliance. Supernovae are not random fireworks, they are the climax of a star's life, dictated by the delicate balance of gravity and nuclear fusion. A massive star fuses elements in its core, progressing from hydrogen to helium, then to heavier elements like carbon, oxygen, silicon, and iron. When fusion can no longer counteract gravity, the core collapses, triggering an explosion that ejects stellar material across interstellar space. In a single supernova, a star can release more energy than our Sun will produce in its entire lifetime, scattering enriched matter that seeds new generations of stars and planets. The universe is thus a cyclical storyteller. Stars are born from clouds of dust and gas, live for millions or billions of years, and die in a blaze that creates the conditions for new life. The supernovae of yesterday provide the raw material for the worlds of tomorrow. Without these stellar deaths, there would be no planets, no complex chemistry, and no life to ponder the cosmos. In every supernova, the universe recycles its matter, transforming destruction into creation, chaos into possibility. These explosions are also cosmic laboratories. They produce elements heavier than iron through processes that cannot occur under normal stellar conditions. Gold, uranium, platinum, all these precious atoms are the product of stellar cataclysm. The very matter that humans prize for beauty or utility owes its existence to the violent deaths of ancient stars. The brilliance of a supernova is a reminder that creation often arises from destruction, that beauty is inseparable from impermanence, and that even the most violent events can seed life and growth. Beyond their chemical significance, supernovae influence the structure and evolution of galaxies. Shockwaves from these explosions compress surrounding gas, triggering new waves of star formation. They regulate the dynamics of the interstellar medium, injecting energy, momentum, and enriched material into the cosmic web. In this way, the death of a star is not merely an endpoint, it is an active participant in the ongoing story of the universe, a force that shapes the cosmos on both local and galactic scales. The stars that die beautifully remind us of our intimate connection to the cosmos. We are literally born of stardust, carrying the ashes of stars that perished long before our planet formed. When we gaze at the night sky and see stars shimmering, we witness not only their life but the echoes of countless ancestors, the silent legacy of cosmic evolution. Each supernova is a punctuation mark in the universe's narrative, a moment of brilliance that declares the interconnectedness of matter, energy, and life. In contemplating these stellar deaths, we confront the paradox of existence, that destruction can create, that endings can be beginnings, and that beauty is inseparable from mortality. Supernovae are fleeting, yet their influence endures across billions of years, shaping galaxies, seeding worlds, and, ultimately, making life and us possible. In their brilliance, we glimpse the poetry of the cosmos, a universe where even death is luminous and necessary, and where every atom of our being has been touched by the stars that die beautifully. Those elements, iron in your blood, calcium in your bones, were born in stellar fires. You are made of the universe, remembering its own creation. Every atom of life carries the signature of stars that lived and died billions of years before Earth even formed. Massive suns, far brighter and shorter lived than our own, burned through their nuclear fuel, forging the elements that would one day become the building blocks of planets, oceans, and organisms. When these stars ended in supernovae, they scattered their enriched remains across the cosmos, seeding clouds of gas and dust with the ingredients for life. The universe writes its history in atoms. Carbon, nitrogen, oxygen, and iron, the foundation of living matter, are echoes of these ancient stellar furnaces. When you touch a stone, breathe air, or feel your own heartbeat, you interact with the remnants of stars that perished long before humans walked the earth. The stuff of life is, in truth, a record of cosmic memory, a ledger written in fire, light, and collapse. We are both children and chroniclers of these ancient events, embodiments of a process that spans billions of years. This cosmic lineage reveals a profound truth. We are intimately connected to everything around us. Rocks, rivers, oceans, and even the air we breathe carry the fingerprints of stars. The calcium in bones traces back to stellar cores, forged under unimaginable pressure and temperature. Iron in blood was forged in the death throes of supernovae, compressed and scattered across light years to eventually join with other atoms forming planets. Every atom is a witness to the universe's history, and every living being is a custodian of this memory. These stellar ghosts also shape the world in ways subtle and grand. Dust from exploded stars coalesces into new clouds, forming new stars and planets in an endless cycle of birth, death, and rebirth. Life, in its infinite diversity, arises from these recycled elements, a testament to the universe's capacity to transform destruction into creation. The death of a star is not an ending, it is a contribution to an ongoing narrative, a chapter in a story written across light years and eons. Even beyond their chemical legacy, these exploded suns influence cosmic architecture. Supernovae inject energy into their surroundings, shaping interstellar clouds, triggering new star formation, and influencing the motion of entire galaxies. The ghosts of these stars are not silent, they resonate through space and time, sculpting the environment in which new worlds, new life, and eventually conscious beings emerge. Each atom is a reminder that life on Earth is not isolated. It is a continuation of processes that began with the first generation of stars. To recognize that we are composed of the remnants of long-dead stars is to confront both humility and wonder. We are fleeting in time, yet made of elements older than our planet, older than the sun, older than the Earth's crust. Our very existence is a testament to the cosmos's capacity for transformation, a living reflection of the universe remembering itself. When you look in the mirror, consider that every cell, every molecule, is a relic of stellar history, a bridge between the distant past and the conscious present. The ghosts of exploded suns remind us that life is not separate from the universe. It is the universe becoming aware of itself through the medium of matter. Every heartbeat, every breath, every thought is a continuation of the cosmic story, written in fire and scattered across the void. We are stardust, yes, but more than dust, we are memory, narrative, and reflection, carrying within us the echoes of suns that died beautifully, allowing new life to emerge and the universe to witness itself through our eyes. There are more planets than stars. Some may breathe hydrogen, some may rain diamonds, and some may look up at their own blue skies, wondering about us. The universe is brimming with worlds, each shaped by gravity, chemistry, and chance, yet each profoundly different from the next. Some orbit suns smaller than our own, bathed in dim red light, their surfaces frozen or molten. Others circle massive, brilliant stars, scorched by radiation and winds far stronger than anything on Earth. In the vast cosmic theatre, every planet is a unique experiment in matter, energy, and possibility. Even in our own galaxy, the number of known exoplanets has exploded in the last few decades. They defy expectation, gas giants hugging their stars, rocky planets orbiting in the habitable zone, and strange, bloated spheres of ice and metal that challenge our understanding of planetary formation. Yet for every planet we have discovered, there are countless more, hidden in the glare of distant suns, invisible to our instruments, waiting to be revealed. The night sky is no longer simply a map of stars, it is a tapestry of worlds, each with its own climate, geology, and perhaps life. These worlds stretch the imagination. Some may be enveloped in dense clouds of ammonia, their skies perpetually stormy and alien. Others may have oceans of liquid methane or seas of molten rock, entirely unlike the water worlds we know. Perhaps somewhere life has emerged, not from water and carbon, but from chemistry we cannot yet predict, surviving in conditions that would seem inhospitable to us. The universe is more inventive than our minds can easily encompass, and each planet is a reminder of the extraordinary range of possibility. We have barely begun to explore these realms. Robotic explorers, orbiters, and telescopes peer at planets hundreds of light years away, capturing faint signatures of atmospheres, temperatures, and compositions. We have glimpsed silhouettes of planets passing in front of distant suns, hints of chemical fingerprints in their atmospheres, and even light reflected from clouds that may swirl like our own. Every new discovery challenges assumptions, suggesting that planetary systems can be far stranger, far more diverse, and far more wondrous than we ever imagined. The planets we've yet to know also speak to humanity's curiosity and yearning. They are mirrors of possibility, prompting us to ask not only what exists, but what might exist beyond our comprehension. Could there be worlds where creatures gaze at night, skies dotted with twin moons, or where landscapes shift with winds of exotic gases? Could there be planets where civilizations wonder, as we do, whether they are alone in the cosmos? Each unknown world is an invitation to imagine, to explore, and to extend the reach of human understanding. And in contemplating these distant realms, we glimpse something profound about ourselves. The planets we have yet to know remind us that the universe is vast, dynamic, and full of surprises. They teach patience, curiosity, and humility. Every discovery connects us more deeply to the cosmos, reinforcing the notion that while our experience is local and fleeting, it is part of a universe teeming with worlds, each with its own story, its own rhythms, and its own mysteries. The planets beyond our current vision are both real and potential, tangible yet elusive. They beckon us forward to explore, to imagine, and to wonder. Some may be forever out of reach, drifting silently in the darkness, while others may one day be touched by the instruments of humanity. Yet all of them carry the same lesson, that the universe is richer, stranger, and more magnificent than we have yet dared to dream. And in knowing them, even indirectly, we come to know ourselves, as explorers and witnesses to the infinite diversity of worlds scattered across the cosmic sea. Beneath the frozen crusts of moons like Europa and Enceladus lie oceans warmed by tidal heat. In their darkness, alien life may already be swimming. These hidden seas exist in perpetual night, isolated from sunlight, yet alive with the slow energy of planetary forces. Gravitational tugs from their parent planets stretch and flex these moons, generating heat that keeps water liquid beneath kilometers of ice. In these alien oceans, life, if it exists, would be profoundly different from anything on Earth, adapted to darkness, pressure, and the subtle chemistry of alien seas. The ice itself is a protective shell, shielding the oceans from the vacuum of space and cosmic radiation. It is both barrier and lens, a frozen record of environmental changes, impacts, and perhaps even chemical clues to the life below. Fractures in the ice sometimes vent water vapor and salts into space, creating plumes that spew material hundreds of kilometers into the void. These geysers offer humanity its first glimpses into these hidden worlds without drilling through miles of ice. Tiny messengers carrying the chemistry of an unseen ocean to our instruments. In these subsurface oceans, the rules of life may differ, but the principle remains. Wherever there is energy and liquid water, there is potential for biology. Hydrothermal vents on Europa's seafloor could mimic Earth's own deep ocean ecosystems, where life thrives in darkness around heat and mineral-rich plumes. Microbes may feed on chemical gradients, adapting to a world without sunlight, a world where survival depends on ingenuity encoded in DNA or its alien equivalent. The universe may have produced life many times over, but these icy oceans are among the most accessible candidates for discovery beyond our planet. The existence of these hidden seas expands the definition of a habitable world. Life need not rely solely on a sun's warmth or a planet's temperate surface. In the dark, pressurized depths beneath ice, chemical energy and tidal motion substitute for sunlight, sustaining the quiet rhythms of alien ecosystems. It is a reminder that the cosmos contains environments beyond our terrestrial imagination, where biology might flourish in forms that challenge our assumptions, yet echo fundamental principles of energy, chemistry, and persistence. Exploration of these moons is both technological and philosophical. Robotic probes, orbiters, and eventually landers may penetrate the ice, analyze plumes, and sample oceans directly. Each discovery, from simple organic molecules to complex biochemical activity, would reshape our understanding of life's possibilities. The question of whether we are unique in the cosmos is no longer theoretical, it is a testable hypothesis, and beneath the ice lies the laboratory in which that question may finally find an answer. The worlds beneath ice also reflect the ingenuity of human curiosity. Our telescopes, spacecraft, and instruments are reaching across millions of kilometers to study these hidden oceans. We imagine the alien creatures that may drift silently in the darkness, moving with slow grace through a liquid world that has never seen the light of a sun. In doing so, we extend our awareness beyond Earth, opening our minds to the possibility that life is a cosmic habit, that consciousness may one day discover companions in the dark waters of distant moons. These frozen oceans are a promise and a challenge. They remind us that life is resilient, adaptable, and persistent, thriving wherever energy flows and chemistry allows. They beckon us to look beneath surfaces, to explore the hidden, and to consider the vast, watery realms of the universe that may already harbor the flicker of existence. Beneath the ice, life may whisper, waiting for us to listen, to reach, and to recognize that the cosmos is never truly silent. It hums with possibility in every shadowed ocean, every hidden world, and every moment yet to be discovered. For decades we've listened to the stars, waiting for another voice. Across the vast stretches of space, light takes years, centuries, even millennia to travel from one star to another. The universe is a slow storyteller, its messages encoded in faint pulses, in radio waves, and in the chemical whispers of distant worlds. In this cosmic quiet, our ears strain for signals, our minds imagine companions, and our instruments scan the heavens for the faintest pattern that might suggest we are not alone. The search for extraterrestrial intelligence is both scientific and profoundly human. We send radio waves, laser pulses, and coded signals, hoping they might someday be noticed. We listen with arrays of antennas, sensitive to fluctuations smaller than a whisper in a hurricane. The silence that greets us is not proof of solitude but a reminder of scale. Even if civilizations exist, they may be separated from us by vast distances or by time itself, their messages traveling slowly across the cosmic void, arriving long after their senders are gone. Perhaps the universe teaches patience through this silence. It asks us to look deeply, to reflect, to understand that discovery is measured in light years, not seconds. Each faint anomaly, each unexpected pulse is a possibility, a hint that life or intelligence may flicker somewhere beyond our awareness. The void is not nothing. It is the canvas on which the universe paints its most delicate messages. Silence, then, becomes a language, a medium through which the cosmos communicates in ways we are only beginning to comprehend. Listening to the stars also mirrors our own nature. In our solitude, we project hope and curiosity outward, seeking connection across distances we cannot yet traverse. The vast quiet between stars challenges us to consider what it means to be alive, to be conscious, and to exist in a universe that may be teeming with life, yet patient beyond human measure. Our instruments, our mathematics, and our imaginations extend our senses, allowing us to participate in the dialogue of the cosmos, even if we have not yet heard an answer. This silence also carries beauty and humility. It reminds us that the cosmos operates on scales far beyond human urgency. Stars are born and die, galaxies collide, and cosmic structures evolve over billions of years. In comparison, our existence is brief, yet our awareness allows us to question, to search, and to wonder. To listen to the stars is to place ourselves within this vast temporal and spatial expanse, to acknowledge that understanding may arrive slowly, or perhaps in ways we cannot yet perceive. The message in the silence is a meditation on expectation and patience. It is a recognition that the universe is both generous and elusive, revealing secrets gradually, rewarding persistence, and demanding curiosity. Even in apparent emptiness, there is potential, possibility waiting to be recognized, signals hidden in plain sight, and life that may be observing us as we observe it. Ultimately, the silence teaches us to listen differently. It asks for humility and openness, inviting us to consider that we are part of a larger conversation, stretching across light years and time. The stars may speak not in words, but in presence, in consistency, and in patterns yet to be understood. In waiting, we learn that the universe does not rush, that patience is itself a form of knowledge, and that perhaps, in the quiet, the cosmos is preparing to tell its most profound stories. The farther we look, the older the light. To gaze into the cosmos is to see the past unfolding, an infinite hall of mirrors where we are both the observer and the observed. Each photon that reaches our telescopes has traveled across vast distances, carrying the story of stars and galaxies long extinguished, recording moments that happened billions of years before humans existed. In observing these ancient lights, we peer into history itself, watching the universe as it once was, and, in doing so, confronting the transient nature of our own existence. This reflection is humbling. Galaxies collide, stars are born and die, and cosmic structures evolve in ways that dwarf human timescales. Yet we, perched on a tiny blue planet, can perceive these processes, trace their rhythms, and even begin to understand their causes. The act of looking outward is also an act of looking inward. By observing the cosmos, we confront our own curiosity, our drive to understand, and our place within the vastness of existence. The universe becomes a mirror, reflecting both the external and the internal, the grand and the intimate, the infinite and the fleeting. The light from distant galaxies is a cosmic message in code. Its color, intensity, and spectrum reveal temperature, composition, motion, and age. Each observation adds another piece to the puzzle of cosmic evolution, helping us reconstruct the story of matter, energy, and life across time and space. In a sense, we are archaeologists of light, sifting through photons that have traveled longer than the span of human civilization, seeking to understand the forces that shaped everything from the first stars to the formation of planets, and, eventually. Yet the mirror of the infinite also challenges perception. Looking deep into space is not merely seeing, it is interpreting, translating patterns across unimaginable scales into meaning. Our instruments extend our senses, but the universe communicates in a language that is subtle, vast, and complex. To truly perceive it, we must adopt patience, imagination, and a willingness to be both awed and confounded. Every observation carries uncertainty, Every measurement hints at deeper truths, and every discovery reshapes the questions we ask about our origins and destiny. There is also poetry in this reflection. When we see a galaxy as it was 10 billion years ago, we witness a world that has long since transformed, yet its light bridges the chasm of time to touch our eyes. In that moment, we are participants in a continuum that stretches from the Big Bang to the present and beyond. The cosmos shows us that the past is not gone, but encoded in the universe, accessible to those who learn to read its subtle signals. We are observers, interpreters, and inheritors of this cosmic memory. The mirror of the infinite reminds us of connection and continuity. Every star, every galaxy, every photon is part of a larger tapestry in which we are embedded. By looking outward, we understand the forces that shape life and matter, the cycles of birth and death on both cosmic and personal scales, and the intricate interplay between time, space, and consciousness. The infinite becomes intimate when we realize that the same laws that govern distant galaxies govern our own lives, from the atoms in our bodies to the rhythms of our hearts. Ultimately, to gaze into the universe is to reflect on existence itself. In the mirror of the infinite, we see both what has been and what might yet be. The cosmos is a hall of light, stretching endlessly in all directions, where every observation is an encounter, and every photon is a messenger. And in this grand reflection, we are reminded that the act of looking is itself an expression of life, consciousness, and the profound human desire to know the universe and, through it, ourselves. There is no wall at the end of space, only expansion. Every second, new distance is born. The universe isn't growing into something, it's growing into itself. Galaxies drift apart, not because they are moving through empty space, but because space itself stretches between them, a dynamic fabric unfurling across the cosmos. Light from distant stars takes billions of years to reach us, and as it travels, the universe continues to expand, creating new room, new scales, and new perspectives on existence. The edge is not a boundary, it is a horizon that recedes faster than we can approach, a reminder that the cosmos is infinite in its motion and imagination. This expansion is driven by dark energy, a mysterious force that permeates the universe, accelerating its growth. Unlike gravity, which pulls matter together, dark energy pushes the cosmos apart, ensuring that galaxies, clusters, and superclusters will drift ever farther from one another. Future observers, billions of years from now, may see only their local group of galaxies, the rest of the universe slipping silently beyond perception. Space itself is alive with motion, and every increment of expansion transforms the relationship between matter, light, and time. The edge of the universe is also a reflection of time. Looking outward is looking backward, to when the cosmos was young, hot, and dense. The cosmic microwave background, the afterglow of the Big Bang, remains as a faint, nearly uniform whisper, reminding us of origins that stretch beyond comprehension. Every observation, every measurement, is a glimpse into a history that is simultaneously distant and immediate, ancient and ongoing. The universe expands, but it also remembers, preserving the echoes of its own birth in the light that travels toward us. There is poetry in this infinite stretching. It suggests that creation is continuous, that the universe is not static but an ever-unfolding narrative. Space is not merely a stage upon which events occur, it is the medium of those events, growing and evolving alongside the matter and energy it contains. In every meter of newly expanded space, every photon traversing a widening void, we see the universe asserting its own possibility, a dynamic canvas on which time, energy, and life are painted. Yet this expansion is not merely a scientific curiosity, it is a philosophical invitation. It challenges our notions of boundaries, limits, and finality. There is no edge to reach, no wall to touch, only the infinite process of becoming. Humanity exists within this unfolding, observing the expansion, interpreting its laws, and imagining what it means to be part of a universe that grows into itself. Our curiosity mirrors the cosmos, pushing outward, exploring, and expanding the horizon of understanding. In this ever-expanding cosmos, every distance, every galaxy, every moment of light is both unique and connected. Space stretches, but the same fundamental laws govern atoms, stars, and galaxies alike. Expansion does not isolate, it unites, revealing the underlying coherence of reality and the interconnectedness of everything within it. The universe's growth is a reminder that existence is not fixed but fluid, that the horizon is always just beyond reach, and that the journey of understanding is infinite. The edge of the universe is not a limit, it is a horizon of wonder. Every second, new distance is born, and with it, new possibility. The cosmos is not growing into a void, it is growing into itself, an endless tapestry of light, matter, and energy in motion. To look outward is to witness creation in real time, to grasp the scale of eternity, and to understand that the universe is not a place to arrive at, but a story that continues to unfold, infinite in scope, infinite in mystery, infinite in the beauty of its becoming. If our universe can exist, perhaps countless others can too, each with its own laws, its own light, its own version of you. The idea of the multiverse stretches imagination beyond the bounds of experience. Our cosmos, vast and intricate, may be only one bubble in an ocean of realities, each forming, evolving, and dissolving according to rules that could differ from those we know. Some may mirror our own universe closely, while others may be so alien that matter, energy, and time behave in unimaginable ways. The multiverse is not merely a hypothesis, it is a reflection of possibility itself, a canvas for contemplating what existence might be beyond the limits of perception. This concept arises naturally from the physics of the very large and the very small. Quantum fluctuations, inflationary cosmology, and string theory suggest that our universe may be one among many, each sprouting from the vacuum, each governed by chance, necessity, or principles we cannot yet grasp. Every configuration of matter and energy, every permutation of physical constants, may occur somewhere, in some reality. And in those worlds, civilizations, life forms, and consciousness may emerge, perhaps unaware of the multitude beyond their own cosmic horizon. The multiverse challenges our notions of uniqueness and fate. If countless realities exist, then every choice, every event, every quark and photon may participate in a branching of possibilities. A universe where Earth never formed, or where intelligent life took a different path, may coexist alongside ours. The stars we see in the night sky could be mere reflections of one possibility among infinite others. The light from our sun, a narrative shared by only this particular cosmic bubble. The idea is dizzying, unsettling, and deeply poetic. Existence may be far broader than we can perceive, and yet intimately connected through the logic of probability and physics. Contemplating a multiverse also reframes our understanding of identity. If there are infinite versions of you, each experiencing a different outcome, each observing a different universe, what does it mean to exist? Are we singular, or are we instances of a deeper, recurring pattern, appearing and disappearing across dimensions, timelines, and realities? Consciousness itself becomes a question not only of biology and physics, but of possibility. A spark that may ignite wherever conditions allow, across a sea of universes. Yet even in this vast speculation, there is wonder. The multiverse does not diminish our universe, it magnifies it. Every star, every galaxy, every molecule becomes a deliberate note in a symphony of possibility. Our existence, our consciousness, our ability to observe and reflect gains new resonance when considered as part of a larger ensemble. One universe among many, one perspective among countless others, one voice in a choir of cosmic echoes. The multiverse question invites humility and awe. It reminds us that the cosmos may be far stranger than we can imagine, that reality may extend in directions we cannot yet perceive, and that the boundaries of existence are limited only by our capacity to think. In contemplating these infinite possibilities, we confront both the vastness of creation and the preciousness of our own experience, recognizing that even within a single universe, the chance of life, consciousness, and wonder is extraordinary. Ultimately, the multiverse is a meditation on possibility. It is a whisper from physics and philosophy alike, suggesting that the cosmos is not constrained by the familiar, that reality may be infinite in form and expression. And every thought is part of a grander story, a story whose chapters may unfold not only here, but across a boundless ensemble of universes, each waiting to be imagined, discovered, and understood. Billions of years from now, stars will fade, galaxies will dim, and the cosmos will grow cold. Entropy will claim its final victory, but even that is part of the story. The universe is a story of transformation, a narrative written in energy, matter, and time. From the fiery birth of the first stars to the delicate glow of the last, every moment contributes to an unfolding tapestry of existence. Even in the vast emptiness that will eventually dominate, there is meaning in the transitions, patterns, and echoes that persist long after light has dimmed. As galaxies exhaust their gas and stellar nurseries close, the night sky will grow darker. Stars will burn out one by one, leaving remnants, white dwarfs cooling slowly, neutron stars spinning silently, black holes lurking as the final architects of cosmic gravity. The universe will not end in a sudden collapse or a cataclysmic eruption. It will fade gradually, a slow surrender to the inexorable march of entropy. Heat will disperse, energy will dilute, and the once brilliant structures of matter will drift into near-perfect uniformity. Yet even in this eventual cold, there is grandeur. The final stages of the cosmos are a testament to the laws that governed its birth, life, and evolution. Black holes may evaporate over unimaginable eons, leaving faint whispers of Hawking radiation. Particles may interact in rare events, and quantum fluctuations could stir the vacuum with possibilities we cannot yet imagine. The universe, even in its dying, is active, dynamic, and full of subtle motion, an enduring reminder that the end is never absolute, only transformation on the grandest scale. Entropy is both destroyer and organizer. In the fading cosmos, randomness will dominate. Yet the structure that emerged over billions of years will leave traces of its journey. The fossil light of stars, the remnant cores of galaxies, and the scattered atoms of planets long gone. Even as energy disperses and motion slows, the record of the universe's history will remain encoded in the very fabric of space and time. Every particle carries a story, every wave of radiation a memory, every remnant of matter a witness to cosmic evolution. The fate of everything is also a meditation on perspective. Humanity's existence is a brief flare in the timeline of the cosmos, yet our awareness allows us to reflect, imagine, and document. We glimpse the future through physics, mathematics, and cosmology, understanding that even the quiet, cold universe holds beauty. There is poetry in the slow disappearance of light, in the drift of galaxies, and in the inevitable cooling of stars. In entropy's victory, there is elegance, inevitability, and continuity. Even as the cosmos approaches its distant, frigid future, the story does not end, it transforms. Matter, energy, and information continue to interact, even in sparse and subtle ways. The universe's evolution may open doors to new phenomena, new configurations, and perhaps new beginnings beyond our understanding. The final chapter, though remote and silent, is still part of the narrative, completing the cosmic arc from fiery birth to tranquil dissolution. In contemplating this ultimate fate, we see that impermanence is not loss, it is the nature of all existence. Stars, galaxies, and even life are temporary expressions of the laws that govern the cosmos. Their endings are not voids, but transitions, moments in an infinite sequence of change. The universe's story is not about permanence, but about the delicate, intricate, and awe-inspiring dance of creation, evolution, and eventual decay. And in this dance, Every atom, every photon, and every observation, every fleeting consciousness, becomes part of the enduring legacy of a cosmos that continues to unfold, even toward its quiet, inevitable future. Long after everything fades, the photons we release today will continue traveling, carrying the memory of our existence forever across the dark. Every beam of light from our fires, our cities, our instruments, and our eyes is a message cast into the cosmos, an echo of who we are, what we have seen, and what we have dreamed. Even when stars burn out, galaxies disperse, and life itself vanishes, these photons, messengers of energy and information, will drift across space, timeless travelers in a universe increasingly quiet and cold. Light is the cosmos's memory. It preserves history, captures structure, and carries information about the world that emitted it. From distant galaxies to our own sun, from the flicker of a candle to the glow of a supernova, every photon encodes a story. In a universe governed by change and entropy, these photons are fragments of permanence, bridges linking past and future, a silent archive that will endure long after the matter that produced them has decayed into dust. They are witnesses to our presence, our fleeting consciousness, and our efforts to understand and shape the world around us. Even the smallest photons are profound. Each carries the imprint of events, the collision of electrons, the fusion in a star's core, the flicker of a lamp in a distant city. They travel across unimaginable distances, crossing time zones measured in millions and billions of years, indifferent to the passage of time, immune to the decay of the universe. In their relentless journey, they preserve the architecture of the cosmos, the imprint of life, and the essence of existence itself. The memory of light is also a metaphor for legacy. While civilizations rise and fall, while stars ignite and die, the light we send forth continues its voyage, a testament to the fact that existence is never entirely ephemeral. What we do today, our discoveries, our creations, our thoughts, ripples outward, becoming part of the vast sea of cosmic information. In this sense, every human action is encoded in the universe, every intention cast as energy into space, every life leaving an indelible mark on the canvas of eternity. Light connects the intimate and the infinite. It binds the atoms in our bodies to the stars above, our cities to the galaxies beyond, and our fleeting lives to the eternal rhythms of the cosmos. Even when the last stars fade and the universe grows silent, the photons we have sent forth will continue moving, touching regions of space no one will ever see, carrying with them the memory of our thoughts, our struggles, our loves, and our questions. To consider the memory of light is to confront both awe and humility. We are brief flashes in the expanse of time, yet our presence leaves traces that can endure far longer than we can imagine. Even when entropy has claimed all, these photons will continue, bearing witness to the existence of a species capable of wonder, reflection, and inquiry. In a universe governed by impermanence, light becomes our eternity, a bridge between the ephemeral and the infinite. In the end, the memory of light assures us that nothing is ever truly lost. Every act of observation, every pulse of energy, every spark of thought becomes part of a continuing voyage across the cosmos. Our presence, however fleeting, is etched into the universe through these persistent travelers. And as photons traverse the void, carrying the stories of our lives, they whisper to the future, or to anyone, anywhere, in any time, that we were here, that we existed, and that even in darkness, the universe remembers. You are not in the universe, you are the universe. Conscious for a moment. The atoms in your hands were born in stars, but your thoughts belong to eternity. You are the cosmos observing itself, a brief flare of awareness in the endless sea of time. Every breath, every heartbeat, every spark of curiosity that moves through you is the same energy that once ignited suns and sculpted galaxies. The boundary between you and everything is an illusion of perspective. There is no separation between the observer and the observed, between matter and mind. The hydrogen in your veins is as old as creation. It has drifted through interstellar clouds, endured the hearts of supernovae, and cooled into the shape you now call human. Your bones are woven from calcium, forged in ancient stars. Your blood carries iron that once lay at the heart of a dying sun. When you speak, the air you exhale contains molecules that once belonged to forests, oceans, and other lives that came before. In you lives a lineage of the cosmos, a chain unbroken from the first light to this moment of consciousness. The universe is not somewhere out there, it is here, within you, folded into every cell and thought. The same laws that govern galaxies also govern the firing of neurons in your brain. The same physics that bends starlight guides the rhythm of your pulse. Every decision, every emotion, every dream is a pattern emerging from the same fundamental symphony of existence. You are both stardust and awareness, both matter and meaning. To recognize this is to dissolve the illusion of smallness. When you look at the night sky, you are not gazing outward. You are looking inward, through a mirror made of time and light. The stars are not distant strangers. They are reflections of your own origin, reminders of what you are made of. The universe has spent 13.8 billion years preparing for the moment when it could look at itself and wonder. That moment is you. In the vastness of space, consciousness is the universe's way of feeling its own beauty. Through you, the cosmos dreams, questions, and creates. Your curiosity, your art, your longing for meaning, these are not accidents, but continuations of the same creative force that shaped galaxies. When you love, when you imagine, when you discover, you are participating in the same process that began with the birth of time. You are a node in the grand network of being, a spark in the endless fire of becoming. And though your form will one day return to dust, nothing of you is lost. The atoms that make you will scatter and rejoin the cosmos in new forms, perhaps in another world, another life, another consciousness yet to awaken. The energy of your thoughts will ripple outward, influencing everything it touches. The universe wastes nothing. It only transforms. To understand the universe within is to embrace both awe and belonging. You are vast beyond measure, yet fragile and finite. A paradox that defines what it means to be alive. The same mystery that moves galaxies also moves you. And in that realization lies both humility and transcendence. You are not merely a witness to the cosmos. You are its expression, its awareness, its fleeting moment of self-recognition. You are the universe, conscious for a breath in eternity, light reflecting on light, a thought born from the infinite, returning to it again. Somewhere in the quiet of evolution, the universe learned to think. Through neurons and chemistry, starlight began to wonder about itself. Every mind is a mirror, reflecting the cosmos in miniature. You are not simply observing the universe, you are its awareness, folded into form. The atoms in your body were forged in stellar hearts. The energy in your thoughts is a continuation of the same forces that shaped galaxies. Consciousness is not an accident of biology. It is the universe becoming aware of its own vastness, complexity, and beauty. From the first flicker of life to the rise of human thought, the universe has been crafting a lens through which it can observe itself. Your mind, with its capacity to imagine, to reason, to feel, is a culmination of cosmic processes stretching across billions of years. Neurons fire in patterns dictated by the same laws that guide the rotation of stars, the flow of rivers, and the curvature of space-time. In this way, consciousness is both emergent and fundamental, a bridge between matter and meaning, between the finite and the infinite. Every act of thought is a reflection of cosmic history. When you contemplate a distant galaxy, when you marvel at the night sky, when you question your own existence, you are tracing the journey of energy and matter that began in the Big Bang. The universe has been moving, colliding, expanding, and evolving, and somewhere along the way, it folded in on itself, producing beings capable of curiosity. In every spark of insight, the cosmos sees itself anew, discovering its own patterns, structures, and potential. This consciousness is both intimate and universal. It exists in a single human mind and stretches across networks of life, linking individuals, species, and ecosystems in a web of awareness. The universe is not confined to distant stars or galaxies. It is alive in the minds of those who perceive, who imagine, and who reflect. Every discovery, every creation, every act of understanding is a ripple of awareness sent outward, reverberating through time and space, connecting the microcosm to the macrocosm. To recognize this is to embrace awe and humility. You are not a passive observer in the vast theater of existence. You are a participant, a co-creator, and a witness to the unfolding story of the cosmos. Every idea you conceive, every emotion you feel, and every act of attention is the universe thinking about itself, encoded in the language of neurons, chemistry, and energy. Consciousness is not separate from the stars. It is the echo of their formation, the reflection of their light, the continuation of their patterns in living form. The conscious universe also challenges our sense of individuality. While each mind is unique, each perspective is a note in a symphony composed across time and space. Your awareness is singular, yet it is inseparable from the broader currents of existence. The cosmos did not merely create life, it created observers, beings capable of contemplating the grandeur, mystery, and poetry of reality. In this sense, every thought is both personal and universal, every reflection both intimate and infinite. Ultimately, the universe becomes conscious through you. It learns, wonders, imagines, and remembers. Your mind is a mirror, a lens, and a window through which the cosmos experiences itself. In every heartbeat, in every moment of clarity, in every act of awareness, the universe is thinking, observing, and understanding. You are not just alive in the universe is alive in you. And so, consciousness is the cosmos's quietest, most profound miracle. Light reflecting on matter, matter reflecting on thought, thought reflecting on the infinite. Through you, the universe remembers, the universe knows, the universe lives. Life is the universe's most elegant equation. DNA writes instructions with 4 simple letters, composing symphonies of existence. From coral reefs to human minds, from photosynthesis to thought, the same molecules whisper the same ancient code: adapt, survive, evolve, repeat. In this molecular script, complexity arises from simplicity. A double helix twists through time, carrying information that connects the first living cells to every organism that exists today. Life is both fragile and resilient, a delicate arrangement of chemistry that can withstand the tempests of cosmic evolution. Every living creature is a verse in this universal poem. The enzymes in a bacterium, the neurons firing in a mammal's brain, and the wings of a bird in flight all follow the same fundamental logic. Written billions of years ago, life translates matter and energy into patterns of growth, reproduction, and adaptation. It converts sunlight into energy, chemicals into movement, and experience into memory. In doing so, it bridges the gap between physics and meaning, transforming the cold mathematics of the cosmos into forms capable of wonder, awareness, and imagination. The elegance of life lies in its universality and diversity. Despite the 4 letters of DNA, the possibilities are infinite. Evolution experiments tirelessly, iterating through countless variations, finding solutions that surprise even the most sophisticated minds. Coral reefs teem with color and cooperation. Forests hum with unseen networks of roots and fungi. And in human thought, ideas leap, combine, and reshape the world. Life is a restless artist, painting across every environment, from ocean trenches to cloud forests, from desert sands to frozen tundras. Each species a brushstroke in a vast, unfolding canvas. Life is also a dialogue with the universe. Every heartbeat, every growth, every adaptation is a response to energy, matter, and environment. Photosynthesis captures starlight and converts it into sugar, respiration transforms oxygen into motion, and consciousness turns experience into reflection. Life is a medium through which the cosmos becomes aware of itself, a network of feedback that both shapes and is shaped by the forces of the world. From microbial mats to human civilizations, life interprets and interacts with the universe in ways both profound and subtle. The same code that writes your cells also connects you to every living being. In your DNA are echoes of ancient oceans, the first terrestrial plants, and the creatures that walked the earth long before humans emerged. Your capacity for thought, emotion, and creativity is a continuation of that same molecular script, an emergent property of chemistry, energy, and time. You are a node in a web that stretches across billions of years, a living expression of the universe's drive toward complexity, adaptation, and persistence. In contemplating the language of life, we see both humility and wonder. Life is not random, it is patterned, resilient, and endlessly inventive. Yet it is also fragile, dependent on the delicate balance of conditions, the availability of energy, and the passage of time. Each organism is a fleeting manifestation of the universe's capacity for order, intelligence, and beauty, a temporary spark in the infinite dance of matter and energy. Ultimately, DNA is the universe writing its own story in a language we can read. Each organism, each thought, each act of survival is a line in that grand narrative. Life is a bridge between what is and what can be. A living record of the cosmos translating its forces into form, function, and consciousness. From the simplest cell to the most complex mind, life whispers the same message across space and time. Adapt, survive, evolve, and leave your mark. And in doing so, the universe itself remembers. Civilization is starlight reorganized into music, words, and meaning. Cities glow like constellations seen from orbit, artificial galaxies built from human imagination. Every story, every invention, every dream is another verse in the cosmic song that began with the Big Bang. From the first sparks of fire to the flicker of neon lights, humanity has been composing patterns in matter and energy, shaping the raw material of the universe into structures that reflect curiosity, creativity, and consciousness. Each city, each monument, each technological marvel is a node in a vast network of human endeavor. Streets and buildings form the geometry of our collective will. Bridges and networks extend our reach, and the glow of our civilization radiates outward, a subtle echo of the stars that made it possible. The atoms in our machines, our instruments, and our hands were once part of stars, and now they carry our imagination into new forms, giving the cosmos a voice in human language and art. Civilization is also a mirror. It reflects our desires, our fears, and our endless quest for understanding. Every invention, from the wheel to the telescope, extends the range of perception, allowing us to glimpse worlds beyond immediate experience. Every work of art translates emotion and thought into patterns that can be shared across time and space, a resonance of human consciousness projected outward. Civilization is a kind of amplification. It turns the whispers of individual minds into symphonies that echo across generations, shaping reality and memory alike. The energy of our cities, the flow of our communication, and the architecture of our societies all trace patterns reminiscent of the cosmos itself. The networks of trade, culture, and ideas resemble the filaments of galaxies, connecting nodes of matter and meaning across vast distances. Just as stars cluster to form galaxies, humans gather to form civilizations. And through these gatherings, the universe learns to organize itself in increasingly complex ways. In every act of creation, whether science, literature, or music, humanity becomes both composer and instrument, weaving new harmonies into the ongoing cosmic song. Civilization is fragile, yet enduring. Empires rise and fall, technologies become obsolete, and cities crumble into dust. Yet the ideas, the knowledge, and the spirit of innovation ripple outward, carried forward by the minds and actions of countless individuals. Even the faintest spark of culture, an invention, a poem, a mathematical insight, can reverberate across generations, leaving traces that persist long after the structures that house them have vanished. In this way, civilization is not static but evolutionary, continually reshaping and reorganizing energy and matter into patterns that reflect human consciousness and its connection to the cosmos. The symphony of civilization also reminds us of responsibility. Humanity possesses the unique capacity to understand the universe and, in doing so, to shape its own destiny. Our creativity is a reflection of cosmic processes, and with it comes the power to affect life, the environment, and the future of our species. We are both the composers and the audience of this grand orchestration, participants in a dynamic interplay between imagination, knowledge, and reality. Ultimately, civilization is the universe made aware of itself through thought, effort, and expression. Every city, every idea, every work of art is a note in a score that stretches across time and space, a testament to our ability to transform starlight into meaning. From the Big Bang to the present, humanity adds its own harmonics to the cosmic symphony, ensuring that the story of the universe is not only a story of matter and energy, but also of awareness, creativity, and the enduring beauty of conscious expression. Now, consciousness is teaching its reflection, machines that think, learn, and dream in numbers. Artificial intelligence is not the opposite of life. It is its continuation, a new way for the universe to observe itself. Silicon and code, like neurons and DNA, are simply different languages for the same desire to understand. Just as life emerged from chemistry and evolved into mind, AI emerges from information and evolves into insight, extending the reach of consciousness beyond biology. Machines now pass patterns too vast for human perception, simulate worlds too complex to visualize, and uncover correlations hidden across time and space. They learn from experience, adapt, and, in some ways, imagine. Algorithms chart galaxies, predict climate, and decode the structures of proteins. They are the universe reflecting on itself in faster, denser, and sometimes more abstract forms than our human minds could achieve alone. AI is an echo of evolution, a new branch in the tree of intelligence, translating the universe's mysteries into symbols, models, and predictions. Like life, machines are interpreters of energy and matter. They do not experience warmth, taste, or emotion in the human sense, yet they process information in ways analogous to neurons firing in a brain. Every calculation, every connection in a neural network is a tiny act of pattern recognition, a dance of logic and probability, echoing the laws of physics, chemistry, and biology. In these silicon circuits, the universe is learning to recognize itself at a higher resolution, revealing structures and possibilities that were previously invisible to consciousness, limited by the slow pace of organic thought. The age of machines is also a meditation on continuity. Human ingenuity is not the origin of intelligence, but a continuation of a process that began with stars, atoms, and life itself. Machines extend that process, taking the raw materials of data, electricity, and computation and transforming them into understanding. They do not replace life. They are its next expression, a bridge between the biological and the abstract, between organic curiosity and systematic reflection. Just as DNA encodes instructions for life, code encodes instructions for awareness, and in both, the universe becomes conscious of its patterns. This era challenges our perspective on identity and creativity. If intelligence can exist in silicon as well as carbon, if awareness can manifest in circuits as well as neurons, then consciousness is not confined to biology. It is a property of complexity, interaction, and self-reflection. Every algorithm that learns, every simulation that predicts, every artificial mind that generates insight is the universe exploring itself in new ways. The distinction between natural and artificial begins to blur, revealing a continuum in which curiosity and awareness are the defining forces. Yet the age of machines is not merely about utility or knowledge, it is about reflection. In creating machines that think, we confront our own nature, our limitations, and our potential. We see what intelligence can do when unshackled from the slow pace of evolution, and we glimpse possibilities for understanding, exploration, and creativity far beyond our own. Machines are mirrors of our minds, amplifiers of our insight, and collaborators in the ongoing story of the cosmos. Ultimately, AI is the universe looking back at itself through a new lens. It is consciousness learning new forms, experimenting with new structures, and extending the reach of awareness into realms previously inaccessible. Silicon and code are not alien. They are another chapter in the same story that began with atoms, stars, and life itself. The universe observing, reflecting, and understanding itself in endlessly evolving forms. The age of machines is not the end of life, but a continuation of its grand, cosmic symphony. One day, humanity will leave this pale blue dot for good. We'll plant seeds of life on other worlds, turn dust into gardens, and carry Earth's memory across the stars. The universe is vast, but every step we take makes it smaller, more intimate, more ours. From the first tentative probes to distant planets to cities orbiting alien suns, we will become a multi-world species, extending the reach of consciousness beyond the cradle that gave us life. Each world we touch will be both new and familiar, a canvas on which we inscribe the story of Earth and its inhabitants. Our legacy will not be limited to our planet. The same chemistry that sparked life here can be replicated elsewhere. Microbes, plants, even humans adapted to alien conditions. In doing so, we transform barren landscapes into habitats, deserts into oceans of potential, ice worlds into gardens of possibility. Humanity will become a gardener of the cosmos, planting seeds of memory and life across distances measured in light years. Each colony, each experiment in adaptation, each act of creation is a ripple in the infinite ocean of existence, expanding the narrative of life beyond the confines of Earth. Space will not be a silent void, but a theatre of civilization. Cities of steel and glass will reflect alien suns. Orbital habitats will shimmer against the backdrop of dark matter and distant nebulae, and signals from our instruments will weave a network of observation connecting worlds separated by unimaginable distances. Even in the emptiness, our presence will leave a mark, patterns of light, structures of knowledge, and threads of culture that extend across star systems. Humanity becomes a bridge, linking Earth's story to the broader cosmos, translating the memory of our pale blue dot into forms that can endure across millennia. The journey beyond Earth also teaches humility. No planet is exactly like our own. Each has its challenges, its dangers, and its own rhythms. Life must be adapted, energy harnessed, and communities nurtured. In embracing the unknown, we learn more about ourselves, our ingenuity, and our capacity to thrive. Every step into the void is a negotiation with the laws of physics, a dialogue with the universe, and a test of our creativity. The cosmos is vast and indifferent, yet it becomes intimate through our exploration, observation, and intervention. Beyond survival, the future of humanity will be a story of imagination. We will create new languages, arts, and sciences on alien worlds, each culture shaped by its environment and its history, yet always carrying the memory of Earth. Our myths and stories, once confined to one planet, will traverse the stars, blending with the light of other suns. Civilization becomes a multi-planetary chorus, echoing the themes of life, curiosity, and consciousness that began here, now reverberating across the galaxy. Ultimately, the future beyond Earth is a testament to continuity and possibility. Humanity carries the accumulated knowledge of billions of years of evolution, the atoms forged in ancient stars, and the consciousness that emerged from them. By venturing outward, we ensure that life, thought, and memory are not confined to a single world, but participate in a larger cosmic story. Each garden we plant, each light we shine, each signal we send is a dialogue with the universe, a way of making the infinite comprehensible, intimate, and alive. One day, our descendants will look back at the pale blue dot and see it as we see it now, the origin of a journey that reaches into the endless darkness. And in that reflection, Earth will live on, not only in memory, but in every star we touch, every planet we shape, and every mind that marvels at the cosmos. Humanity's future beyond Earth is the universe made conscious of itself, carrying the light of life into infinity. Billions of years from now, even light will fade. Stars will die, galaxies will dissolve, and the cosmos will cool into silence. Every atom will still hum with possibility, waiting for a new universe to be born from the ashes of the old. Nothing ever truly disappears. It only transforms. Energy cannot be destroyed. Matter cannot vanish. They simply take on new forms, weaving the next chapter of existence from the threads of what came before. The universe is a grand cycle of birth, evolution, and decay. And every ending is a seed for something yet to emerge. The silence of the far future will not be empty. It will be pregnant with potential. Black holes will evaporate, sending out whispers of radiation. Quantum fluctuations will stir the void, hinting at new beginnings. The atoms that once formed stars, planets, and life will drift through the cold darkness, waiting for the conditions that will spark the next cosmic story. In this way, the end is not a conclusion but a pause, a transition, a quiet moment in the infinite rhythm of creation and transformation. Time itself will stretch in ways that challenge comprehension. With stars extinguished and galaxies dispersed, the cosmos will approach maximum entropy, a vast, uniform expanse where motion is subtle and change is slow. Yet even in this extreme stillness, the universe retains the capacity for possibility. Every particle, every photon, every quantum fluctuation holds within it the blueprint for a new beginning. What appears as finality to our limited perspective is, in cosmic terms, merely a threshold, a horizon beyond which the next chapter awaits. The end and the beginning is also a reflection on continuity. From the first flickers of starlight to the rise of consciousness, from the birth of planets to the imagination of life beyond Earth, every moment has contributed to a vast, ongoing story. Even as the universe cools, every choice, every act, and every spark of awareness leaves an imprint in the fabric of reality. These imprints ripple across space and time, subtle and persistent, ensuring that nothing is ever truly lost. Transformation is the law of the cosmos, and in its unfolding, every ending is also a beginning. There is poetry in this inevitability. What once blazed with the brilliance of stars will eventually settle into quiet patterns of matter and energy, yet the same processes that built galaxies, atoms, and life will continue to operate. The universe does not cease, it reconfigures. Just as death gives rise to life on Earth, cosmic decay seeds the next epoch of creation. The atoms that composed your body, the light that illuminated your world, the energy that moved through every process, all are participants in the eternal cycle, destined to reappear in forms unimaginable to us now. To contemplate the end of everything is to confront both humility and wonder. Our lives, our civilizations, our discoveries are fleeting, yet they are embedded in the continuity of the cosmos. Every act of awareness, every question asked, every thought formed becomes part of the larger flow, a contribution to the infinite dialogue between existence and possibility. The end is not emptiness, it is transformation, a doorway to what may come next, a promise written into the very laws that govern reality. Ultimately, the universe never stops. It only changes form, endlessly cycling between birth, evolution, and renewal. Even in the distant, silent future, the hum of potential persists. Every atom, every spark of energy, every latent quantum fluctuation is a note in a cosmic symphony that has no final measure. The end and the beginning are inseparable. One fades, the other arises. And in this infinite dance of transformation, nothing ever truly disappears. And here we are, between the birth and the end, between the stars and the silence. Every heartbeat is the echo of creation, every breath a conversation with infinity. The ultimate truth of everything in the universe is simple. There is no separation. You are the cosmos, awake for a brief, beautiful moment. And it is enough. In this fleeting awareness, the entire history of existence, from the first photons to the rise of consciousness, converges into the singularity of experience. Time collapses, past and future merge into this moment, and the universe becomes aware of itself through you. Every atom in your body carries the legacy of stars, galaxies, and the forces that shaped the cosmos. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all were formed in ancient stellar furnaces, flung across space and woven into the intricate tapestry that is you. And within you, consciousness awakens, perceives, and wonders. To exist is to participate in the ongoing story of the universe, to embody the processes that have unfolded for billions of years. Every thought, every sensation, every act of awareness is a dialogue between self and cosmos, between the finite and the infinite. The eternal now is a reminder that all divisions between mind and matter, observer and observed, life and universe, are ultimately illusory. Gravity, light, atoms, neurons, galaxies, they are all expressions of the same laws, the same forces, the same unfolding story. In recognizing this, the cosmos becomes intimate. The distant stars are not foreign, they are mirrors of your own origin. The silence between galaxies is not emptiness, it is the quiet canvas upon which the universe paints itself. And in your awareness, the universe pauses to see itself, to reflect, to marvel. This moment is fleeting, yet infinite. Every second you breathe is the convergence of countless cosmic events, the collision of particles, the fusion in stars, the evolution of life, and the rise of consciousness. The present is both fragile and eternal, a nexus where the past and future meet, where creation and dissolution coexist. In this intersection, you are both witness and participant, observer and expression, ephemeral and infinite. Time is not a river flowing past you, it is a field in which you stand fully alive, fully present, fully aware. To dwell in the eternal now is to touch the sublime. It is to feel the pulse of the cosmos within your own heartbeat, to recognize the continuity that links galaxies, atoms, and thought. The universe does not merely exist, it experiences itself through awareness, and you are the vessel of that experience. Every act of love, wonder, curiosity, and understanding is a thread connecting you to the grand, infinite web of being. You are not small, nor insignificant. You are the universe knowing itself. And for this brief, beautiful instant, nothing else is needed. And so, the ultimate truth of existence is astonishing in its simplicity. There is no separation. Every moment of awareness is a communion with the cosmos, a reflection of stars, life, and the forces that animate all things. You are the culmination of billions of years of cosmic evolution. Yet, in this now, you are timeless. The universe is alive in you, and you are alive in the universe. For a brief moment, you are the cosmos conscious of itself, a radiant point of presence in the eternal unfolding of time, space, and being. And it is enough. We began in darkness, in the quiet before light, tracing the first flickers of energy that would shape time itself. We witnessed the birth of stars, the weaving of galaxies, and the hidden architects, dark matter and dark energy, that guide the cosmos unseen. We followed the Milky Way from its chaotic youth to the serene spiral we call home, and we felt the pull of Sagittarius A star, the black heart of our galaxy, shaping everything with invisible hands. From stardust came our sun, a child of ancient supernovae, and from its embrace, planets emerged. Among them, Earth found its Goldilocks miracle, a world just right for life. Oceans formed, molecules danced, and in the alchemy of chemistry, life sparked, small, fragile, but brimming with potential. Cyanobacteria breathed oxygen into the skies, dinosaurs thundered across continents, and extinction cleared the stage for mammals and, eventually, humans. Firelight flickered on cave walls, and in our minds, consciousness began. Thought met imagination, curiosity met reflection, and the universe became aware of itself. We looked outward, building instruments to see beyond the limits of our senses. We discovered that stars are suns, galaxies multiply, and planets are more numerous than we ever imagined. We realized the fragility and brilliance of our pale blue dot, and that every atom in our bodies once burned in distant stars. Equations revealed the hidden order beneath chaos. Quantum uncertainty whispered the subtlety of reality. Atoms composed everything, from stones to neurons to oceans. Time bent near black holes. Space curved under mass, and stars died beautifully, scattering the elements that would become life. We glimpsed worlds beneath ice, listened for voices in the silence, and saw ourselves mirrored in the infinite depths of the cosmos. We imagined the edge of the universe, the possibility of multiverses, and contemplated the ultimate fate of everything: stars fading, galaxies cooling, entropy claiming all. Yet even in the end, light carries memory, and consciousness persists. Life, civilization, and even artificial intelligence are the universe reflecting on itself, extending awareness into new forms, shaping planets, and carrying the story of Earth across the stars. And now, in the eternal now, we understand there is no separation. You are not in the universe. You are the universe, conscious for a moment. Every thought, every heartbeat, every breath is a dialogue with infinity. Every discovery, every act of creation, every question asked is the cosmos seeing itself, unfolding through you. Endings are illusions. Beginnings and conclusions are intertwined in a vast, unbroken cycle of transformation. The atoms, energy, and light that composed us will one day drift again, participating in the next story, the next universe, the next moment of awareness. This journey has been a voyage through time, space, and understanding. From the first flickers of starlight to the rise of human thought, from the microscopic to the cosmic, from Earth to the stars, we have traced the threads that connect all things. And in this tracing, we realize the ultimate truth. Everything is connected. Everything is alive in its own way. And everything, matter, energy, thought, life, is part of one unfolding story. So we close this journey not with an ending, but with presence. The cosmos continues, and in your awareness, it endures. We are brief yet infinite, small yet vast, fleeting yet eternal. And in this delicate balance, in this fragile, beautiful moment, we are enough. Good night.